everybody, I'm Scott Stanchfield, and welcome to our domain-specific language class. I can't remember exactly what we called the class. I think it was programming with domain-specific languages. They always make me put extra words in. The one for the Android class is like 3 miles long, and it's like every time you get an email from me, it has the 3 miles long, colon, whatever the subject is, and I hate that. But anyway, welcome to the class. Thank you for taking a chance on this, and we'll see if it's worthwhile, huh? I am making this up on the fly, so I have an outline for what I'd like to do. Hello, hello. How's the temperature for everybody? Everybody good?
Yeah, pretty good.
We got a lot of thumbs up. That sounds great. Thanks, Tracy. Yeah, I've got a what I think is a really good outline for the class. Eventually, I'm going to send it to you guys just so you have an idea of the topics I want to cover. I'm not quite sure how much time each topic is going to take yet, so I don't really have a good idea in my head of which weeks are going to be which topics. So we'll just kind of flow through it and see what happens. When it comes time for assignments, I'm going to try to make sure that we've covered everything we need for the assignment by the time the assignment comes. Okay, so this is my contact information. Let me kill the lights a little bit here. I think it's this guy. Yeah, perfect. This is my contact information. Scott@javadude.com is my email. 301-609-0545 is my phone. Please, if you're going to call 9 a.m. to 9 p.m., preferably more toward the middle of the day, because I do like to sleep late. I'm one of those people. But if you want to contact me for questions, what I ask everybody to do is, first of all, Google. And hopefully people taking this class are probably going to be in a place where they've Googled a lot. First of all, Google, because sometimes it's going to be a simple thing that I would Google and tell you the same answer. Second, discussion forums. On the website, there's going to be discussion forums for each assignment and a general discussion forum. Post there, because then chances are if one person has a question, other people have the same question. So that way everybody gets the answer to the question. If it's something very particular like why did I get this grade on something, then yeah, email me or call me. But if it's something that it's not very, very specific to the way your application is coded, then please go on the forums with that. If it's a case where you have to show me source code, then don't go on the forums, basically. Okay, so about me. They always make us put these in for the online class, kind of personalizes them, It's a great picture of me going. I've been a developer since 1989 after I came out of the University of Michigan. Started at IBM and went several places from there. When I was at IBM, I did my master's course. Let's see, do I have that in here somewhere? Let me just go through what my bullets say, and then I'll figure out what to fill in, because I can't remember what this slide had on it. I was a Java instructor for 4 years doing corporate training. This was in the late 90s, early noughts. And that feels weird saying noughts, but I guess that's the only way you say it. The early double O's, whatever. And I was just flying all over the place, teaching Java. Some of the best places I got to visit through that were Australia and Germany and England. A lot of bad places. I got to go to Peoria, Illinois. My apologies to anybody if that's their hometown. Not a fan. They were nice people there, but boring. I taught at Montgomery College for a couple years before I started at Hopkins, and I've been teaching here since 2002, doing various classes. I did the design patterns class for quite a while. I've been doing the Android class. I'm not doing design patterns anymore because when we did the online version of it, the other instructor and he had started it. He suggested it literally 5 minutes before I suggested the class, so he got it. But when we did the online class, we had very different styles of teaching it, and so I backed out and said, hey, why don't you do it so it's a consistent feel throughout the course instead of every other module having a completely different feel. These are just some pictures. Again, they told me to show pictures. This is me climbing in the trees at Sandy Spring Adventure Park. Has anybody ever been there? It's a great place. It's down near Olney in Sandy Spring. It's right next to the Sandy Spring Friends School. They have 14, I think, or more than that, maybe, courses. They're ropes courses where you have obstacles like this, and you can do zip lines between the different. Each course has several zip lines, so it's a blast. Some of the courses are really, really hard. They have like a diamond rating type system on them, colors and diamonds. But if you enjoy, rope type courses, rope bridges, zip lines, great place to go. And it's pretty close too. This is me swing dancing with my dad's girlfriend. And I've been swing dancing since the early 90s. Anybody here swing dance? You really should. It's a lot of fun. This is me riding a roller coaster, one of my other fun hobbies. This is a great picture. I don't know if you can really make it out, but the faces on this are just amazing. Especially this person over here holding their head like their head's going to explode. This ride, the Dominator down at King's Dominion, the point where they put the camera is a point where you're just really just, the speed at this point, hitting a curve was just crazy. So everybody's getting the complete wind-blown, like, this is awful type look on their face. So I'm glad they put the picture there. This was back when I was working as Brother Berenstain Bear at Cedar Point. This is without the head on the costume, but I did that for a summer. Before that, I was actually working at Chuck E. Cheese, and I had done the Chuck E. Cheese costume a lot. So it got me a costuming job at Cedar Point, which was a blast, and that's when I found out I liked roller coasters. So let's see. I've worked for several people who are names that you might recognize if you looked in computer science textbooks. Tom McCabe, has anybody ever heard of cyclomatic complexity? He came up with that. He's a mathematician, and it shows. And he believes that everything can be explained through linear algebra, which is what cyclomatic complexity is based on. He doesn't believe that you should take data flow into account. I had several arguments with him about that, and that was quite a joy. It's like he's like, well, linear algebra shows you can test this sufficiently by going through it 2 times and 4 times. And I'm like, if it's a loop, you'd probably want to go 0, 1, and more than 1. And he's like, no, we don't need that. It's like, okay, bye. Frank Dreamer and Tom Pinello came up with LALR parsing. Has anybody here taken a compiler class? Okay, so you're familiar with LR parsing and LL parsing, things like that. We're going to be talking about that in this class. Not as deeply as we do in the compiler class, but we'll be doing a lot of the fun stuff that you do in the compiler. You basically consider this to be the compiler class, the fun parts of the compiler class. But Frank Dreamer and Tom Pinello came up with LALR parsing, and I worked for them out at MetaWare out in California. I was the front-end compiler guy for a little while. I was actually on the C++ standards committee for ISO for C++ 98. If you ever get the wonderful opportunity to work on a design by committee project, say no. Because every meeting of this was, and I went to 2 meetings just at the tail end of it, every meeting was basically, okay, feature X works like this, and then somebody, we had 50 people in the room, somebody raises their hand, but what about this incredibly pathological way of doing things? Everybody's like, oh yeah, we have to support that. So it was a weird process. I'm actually the one person who voted no with comments on the draft before it went to ISO, because every time I heard somebody say something like, we have to fix this, we have to fix this, we have to fix this. And that's the definition of no with comments. Yes with comments means we'd like these to be fixed, but everybody kept saying, we have to fix this before it goes to ISO. And I'm like, that's no with comments. And so had a nice debate, and it was actually a very nice debate. But I ended up voting no with comments. Everybody else said yes with comments because they were done with it. They just didn't want to have anything to do with it anymore. I worked with Terrence Parr at Managed Lang Institute doing training there. He's the guy who wrote PCCTS, which later became Antler. Anybody here used Antler before? And we'll see an Antler example in this first session. I got to know him because I wrote a debugger for Antler. Back when I was doing my master's here in the compiler course, I used PCCTS for my compiler. And when it switched over to Antler, I wrote a Java debugger for it and got to know Tara really well. And then he said, hey, come work for me. I'm like, whatever. That was fun. As you can see, I like to name drop. Your contact information. Please, please, please. I should change that to say check sys, shouldn't I? They finally did change that a couple of years ago to sys. You can see I didn't bother editing this slide. Please check sys. Make sure that your contact information is right. Did everybody here get the welcome email, the welcome announcement in your email?
From you?
From me.
Of course, James, I didn't get the welcome. Yeah.
So I a couple days ago, or actually last week, I sent the welcome email. Some got it, right?
Blackboard's not open for me.
Blackboard is not open for you. Nobody sees it? Huh, because I just fixed it. Now, were you able to see it before today?
Check this morning.
Okay, because there was some people had trouble with it last week, and I had that fixed, and it should be open. If you're having trouble getting to Blackboard, send me an email. That would definitely explain why you're not getting the announcements. Oh, I'm sorry. Blackboard, I'm thinking the other class. I'm teaching the Android class online. That class is the one that I got fixed up. This one I actually haven't set it up yet. So it actually hasn't, so never mind. Ignore the whole thing about the announcement. It's like, I'm going to fix that up tonight. I was planning on getting the website all set up tonight with the syllabus and everything. If you don't see an announcement in the next couple days, send me an email, let me know. But you should be getting an announcement because I'm going to send a welcome tonight when I get everything set up. Okay. Make sure that in ISIS, your email and your phone number are correct. And I use this for all the course communication, so it'll be through any type of announcements. It'll be if I need to contact you personally. I'm just going to use whatever email was inside your SIS contact. Okay, questions on that? Okay. In particular, if for some reason I have to cancel a class, like if we have a snow day, yeah, that'll happen this term. I wouldn't, for some reason, maybe we have a flood, who knows? I mean, there might be some reason that we decide to cancel, maybe I get sick or have to go out of town. Then I'd need to contact everybody. And so what I'll do is I'll send an announcement, and on the announcement I'll say, action, please email me to let me know you saw this. If I don't get a response back, I'm going to try calling you using that, that phone number you give me. And if I can't reach you there, I just have to put a note on the door. Is all I can do. So hopefully, if everything's good, you shouldn't ever have to show up here and to see a note on the door because I hate having people have to travel in. Anybody have to travel any decent distance to get here? You're all pretty local, or where are you coming from? Yeah, 20 minutes, not too bad. It's not like you're in the middle of Virginia. It's like I get some people who are like, yeah, I've been driving here all day. It's like, oh, poor guy. So grading, I'm going to have 5 or 6 programming assignments. I'm probably going to end up with 5. I haven't quite decided yet. I have some ideas what I want them to do. But I haven't completely made up my mind on that yet. These are going to all be graded A, B, C, or F. Actually, they're allowing us to do Ds now, so it's like I may have Ds in there, but it's basically going to be a point grade that equates to a letter. And it will include a plus or minus. I will give you comments on why I graded a certain way, but I will not explicitly say this was worth 2 points, this was worth 5 points, this was worth 1. In the past, I had people complaining about, why did I get 1 point off? I shouldn't have gotten 1 point off. That should only be worth 0, or that should only be worth 1 instead of 2. And it never made any difference in the grade. I mean, it basically what I do is I do something I call subjective grading. I take a look at the assignment, I look at it as a whole, and I write down comments on what I liked or didn't like, and then I decide on a grade. And that's worked great. I haven't had any complaints about it, so I'm going to keep going with that. But what I do like to say is if you get comments back and you think the comments are wrong, tell me right away. Because sometimes I get tired while I'm grading, and sometimes I'll do a copy-paste error. Because I keep a little list, a little notepad open with a bunch of comments I've written for one person and the other person, and then I can just cut and paste them. Sometimes I miss when I cut and paste which comment I mean to apply. So if something looks wrong, just let me know and I'll fix it up. It's not a big deal. I will not, when you do ask me to review it, I'll never take the grade lower, but I may take the grade higher depending on what the comment is. Make sense? Because I don't want you to feel like, ooh, I don't want to say something because he might regrade and grade me lower. It's like, that'll never happen. Grading can take time sometimes. With 5, it shouldn't be too bad for this class. But if there's, I'm not planning on having the assignments build on each other. But if you don't get the grade back from one with a reasonable amount of time to correct those kinds of errors for the next assignment, I won't count them off on the next assignment. If I do for some reason, like if in one assignment I say, hey, you used this technique and it's a bad technique to do and took off for you, and the next assignment I say the same thing, just let me know and I'll fix it up. Your final grade will not have a plus or minus on it. This is something that the university is allowing us to do pluses and minuses on final grades. I tried that for a term or two, and there was a lot of people who really had heartburn with it. A lot of problems with it, like some programs, like PhD programs, didn't know what to do with them because our GPAs still are just on the even numbers. So the GPAs don't include the minuses or pluses. They're just the solid grades, the 4, 3, 2, 1, etc. And sometimes also employers had no idea to deal with them because the employers usually had policies like if you get an A or B, it's full reimbursement, C, you get nothing. Sometimes A is full, B is 80%. I mean, I don't know what you guys have for your reimbursements, but each company had different ways of doing it, and they didn't take into account the pluses and minuses. So that caused heartburn there, so I just said, forget it, I'm just going to go with the straight letters. I do not curve in the class, you get what you get. I should say, unless there's some really, really extenuating circumstances, like sometimes when I'm creating new assignments, maybe I made some bad anticipation, or maybe I anticipated things that you don't know, and everybody did really poorly on assignment because of it. In that case, I may curve it up, or just give everybody, some free points. But in general, no, I don't curve. general grading guidelines. This is just kind of general buckets. Don't come back to me and said, oh yeah, well, I definitely spent time on this, so it isn't a C. So, but these are kind of like in general feel for what it means to have an A. A, on time, working, good design. B, not quite working, maybe the design was a little bad or something like that, or it was a day late and otherwise would have been a B. Every day late is a grade down, so that's 10 points. C comes across as little parent effort. I can't get it to build or execute properly. Maybe it's throwing exceptions or just won't build. The design is really, really wrong. Or day late would have been a B, 2 days late would have been an A. Fs I don't give very often, but sometimes it happens. Usually it's plagiarism. I'll talk about that in a minute. 3 or more days late, or it looks like you started it the day before it was due and basically turned in example code. It's like, I've actually had some people turn in less than example code, and I don't know how that happens. Like, they'll, instead of starting with the sample code that I give them, they start with a blank slate and then turn in like one function, and it's like, yeah, that's an F. But most of the time, that's not going to be a problem. Plagiarism has been an issue, and I want to make sure everybody here understands what plagiarism means. I have had problems in the past where I say to somebody, you submitted somebody else's work as your own. And they're like, yeah, but that's not plagiarism. I'm like, that's the definition of plagiarism. Anytime you represent somebody else's work as your own, that's plagiarism. I mean, it's pretty straightforward. You can bring in other pieces of code from online, from course examples and so on, if you attribute it and if it's allowed to attribute it. So if you're bringing in stuff from a website like Stack Overflow, they have a license that says, yeah, you can copy that stuff in, that's perfectly fine. If you're copying it from some random person's website, make sure they have a statement somewhere that says it's okay to use their code. If you're copying from the course, everything in this course I will have available as Apache 2. So it's, feel free to copy that in, but just put an attribution on it. Just a little single comment that just says, I got this section from, put the website and then the license, and then you're fine. And do that in real life as well. Yes.
Do we need to attribute like the sample stuff from the class stuff?
Yes. Just have a comment saying I grabbed, or this is based on the course example or something like that. So just a real simple little attribution. And I do this for a couple reasons, because I've worked at several companies that don't keep track of these things well. And so I like to push this on people that it's like, you really need to track this because you can get in some serious trouble for not doing this. And if you don't do this and then I notice that your code is copied from somewhere, your grade's going to suffer. So keep that in mind. Anything you submit is your own work. Now, as far as discussing amongst yourself or discussing online, you can discuss the concepts, you can discuss the sample code that I sent, you can discuss what the assignments are, but you cannot work together on the assignments or discuss your code specifics with each other. So don't show each other code. I had 2 terms ago, I think it was 2 terms ago, I had one student who was really having trouble with the concepts. And he had a friend in the class, and he asked the friend to show him his code, and the friend showed him all the code, and the guy copied all the code and turned it in. And they both got in trouble for that. The one who actually got copied didn't fail the class. The other one did because he plagiarized a second time later in the class. But the thing that saved him is like once he had shared the code, he talked to me about it and said, hey, is this okay? And I'm like, no. So it was a 0 on the assignment for him, but it didn't fail the class. So the JHU, has everybody seen the new academic integrity policy? It came out, I guess, about a year ago, maybe a little bit more. And basically it outlines the process for what happens if there's a violation of academic integrity. The big one is plagiarism. There's other things in there, but plagiarism is kind of the biggie. Any type of cheating. The basic idea of the process is that you talk to me, then we'll try to come up with some way of resolving it. If it's an informal resolution, it's nice and easy. I mean, it's basically, you're going to get a note of here's what happened for your particular violation in the class. It doesn't end up going on your transcript. It will go in your academic record to say that there was an issue, but it won't show up on the transcript in any way. If we can't resolve it informally, and it doesn't happen too often, but it does happen. But so hopefully not in this term anything will happen. I like to scare people up front. If the informal resolution doesn't work, then you can have a hearing. And the hearing will, I'd present my side of the evidence, you'd present your side of the evidence, and then we have a panel decide, what goes on there. And depending on how that gets resolved, it can result in further penalties. So it could end up being dismissal. Usually that's not a first time around. But it really, the idea here is just, be aware that this is serious. And the university is getting much more serious on it. Their policy has actually gotten much more formal. But, it is, if there is some misunderstanding between you and me in this, then, there is that hearing process. Okay, any questions? I recommend everybody please read that academic misconduct policy. Let's see. So anything else there? Nope, that's good. So assignment grade areas, so the places that I look at in your code are design. First of all, are you using the types of patterns I discussed in the class? Are you abstracting things effectively / appropriately for what the assignment is? And the design fits the problem. Most of the time this isn't an issue, because if you take a look at what we did for the samples in the class, people are like, yeah, I know the general approach for doing things. Sometimes people decide, oh, well, maybe I don't like that approach, or maybe I have a friend who does it this way, and maybe the friend is way off in left field somewhere. And then that's where this design area could hit you there. Function is probably the easiest for you to determine if you're going to do good on or not. Does it do everything it's supposed to do, and does it even work? Does it crash out of the gate? When I do my testing, I'm not going to do exhaustive testing on things. And for each assignment, I'll be telling you kind of what I'm looking for as far as the functionality. I'm not looking for a lot of edge cases. So it's like if the data coming in is invalid, it's fine if you crash. Unless, particularly for that assignment, I said something about you have to catch these certain invalid conditions. But most of the time, you can assume that I'm going to give you valid input. Okay. If I am going to give you other types of input, I'll let you know up front about it. Okay. All required function is present. In each assignment, I'll have a list of here's everything that has to be done. You have to do it all. You can't just say, oh, well, this shows that I understood the concepts well enough. Sometimes I'll get comments back, I'll say you only did half the stuff, and they're like, well, I've demonstrated that I know what's going on. It's like, that's not valid. It has to hit all the points. Style and coding conventions. Can I read the code? Because, yeah, I do read the code. And especially like if before the assignment's due, you send me the code saying, hey, I'm stuck, can you help me out? And if you ever find yourself in a situation where you're banging your head against the desk, don't bang your head against the desk. Send me a note. Ask me questions. It's like, that's what I'm here for. And if you have any, if it's something that I can't immediately say, oh, you must be doing X, I might ask you to send me the code. Now, for sending the code, I've had lots of problems with Gmail. Sometimes you can zip it up without any type of jars in it, so basically you kill your build directories, and then send it over Gmail. Sometimes you have to rename it. Sometimes not even that works. So easiest thing here is I'll just ask you to submit it on Blackboard, and then I can grab it. Let's see, did you follow the coding conventions? And the main reason that I like to make sure you're following the coding conventions, so I can read it, is not just during grading, but as I said, when you send me things to look at before you submit them. And then timeliness. A day late is a letter grade, 2 days late, 2 letter grades, and so on. Okay, make sense? And it's, if it's more days late, then it's just basically, think of it as just 10% per day. So coding conventions. I just talked about this. Note that third bullet on the bottom there, I may give partial or more credit. If you submit code and I try running and it doesn't work or it doesn't compile, I don't usually just come out and say, okay, 0 doesn't work. I like to try to figure out why, because sometimes it's as simple as just a stupid Boolean variable somewhere. Condition is reversed. And, I go through and try to figure it out and try to get it working. And, sometimes that'll take several tweaks to your code to get it done, but sometimes I'll be like, change this, change this, change this, run, nope, change this, run, nope, change this, oh, there it goes. And then sometimes it's really you were fairly close. I had one person last term in the Android class, their Bejeweled project, it wouldn't run. And they worked on the algorithm section of it and did a lot of stuff basically blind without the thing actually running. And after I tweaked a few things, I mean, I probably spent 10 minutes tweaking it. The thing worked beautifully. I was completely shocked because it's like, they said that they were never able to see anything on the screen, but they thought it through well enough that once I just made a couple tweaks, the thing actually worked. I was just like, wow, that's pretty impressive. Keep in mind that I do have to look at several assignments. Again, this class I got 5 people, so it's not as big a deal. Android class with 38, it's kind of a big deal. Although I got a grader this summer. So coding conventions. I'm not trying to be overbearing on this. So there's just some basic coding conventions I want you to follow. Spaces or tabs, but not both. Don't mix your leading indentation. Right? There's that crazy Linux style of 4 spaces tab, 4 spaces tab. I don't know who came up with that nonsense, but it's dying out, which is good. I haven't seen it as often, but every once in a while, I'm like, ugh. If you do it all spaces for indentation or all tabs for indentation, I can read it just fine. Doesn't bother me. Any type names, so classes, interfaces, enumerations, that type of stuff. Upper camel case, so no underscores in there. Starts with an uppercase, each successive word uppercase. These must be full words. Don't abbreviate, I don't have 2-letter abbreviations for things. Unless it's like a really common abbreviation like URL, then that's perfectly fine. But full words, then I can understand what the thing is. Variables, methods, or functions. These are lower camel case, so draw object, number of objects on screen, something like that. Okay. Make the names be long enough to be descriptive, but not so long that you're throwing in extra words, like this is the number of objects that are currently on the screen. Number of objects on screen is going to be perfectly sufficient for that. Or number screen objects, something like that. Okay. Hey, I just said that. Some exceptions to what I said about the names. I, J, and K for counters and loops, perfectly fine. A current number or a current item in a loop, N is fine. And if you have catch blocks, E for the exception is perfectly fine as well. For your project names, name them HW1, HW2, yada, 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 things like that. Your zip file name should be your last name, dot your first name, dot HW whatever, all lowercase. All of your packages should start with that same name, last name, dot first name, dot HW whatever. Okay. It just makes it easier for me to figure out who's who, who's doing what. Okay. All of your types must be contained inside of a package. Here's some examples of package names. If you want, you can have nested package. See, nested packages is a weird word because it's not really a nested package in Java. It's just a name that has a common prefix. So you can use that same common prefix on any number of packages. My preference in general is fewer packages. I have had students where they'll have 10 classes and every class is in a different package. And it's just a pain to have to keep expand, and click on this. It's like turning into Lewis Black in here. So whatever style you prefer on it, but try not to go overboard on the number of packages. Discussion participation. I like discussions. So it's like, if I'm saying something you don't agree with, or if you think you have something to add on it, like if you have other ideas, please, suggest it. I like, I'm not worried about you asking questions. I know you're going to ask questions. I usually get somebody in a class who asks a lot of questions, but he asks good questions. I mean, every once in a while I get somebody who asks questions, I'm like, let's talk about that offline. I didn't have to do that, I don't think even once with you in the Android class. Because your questions actually added a lot to what was going on, and I like that. So, make comments, suggest alternatives. If you have any feedback on the course in general, especially since this is the first time I'm teaching this class, I'm not, I never know how well it's going to go throughout the term. Hopefully what I decide to talk about is going to be effective, entertaining, useful information. But if there's things that I don't cover that that you would have wanted to see covered, let me know. If there's something that you don't see on the topic list that you've heard of but want me to talk about later in the term, please let me know. Because I'm perfect. My topic list, I'm perfectly willing to adapt throughout the course. So whatever makes this a useful course. Because I'm not one who likes to just talk theory. I like to be pragmatic. So I want to try to show you stuff you can actually really use in your day-to-day programming life. And the closer I can get to that, the happier I'll be, and hopefully the happier you'll be. Again, ask questions at any time. Discussion forums preferred. And if it has to be something that's private, please let me know. I should also mention, as far as things being late, if you know that you're going to have a busy time coming up at work, tell me in advance. If you tell me the day before something's due, oh, work got busy, I'm sorry, it's still, you're going to have to just suck it up. If you know there's going to be like, especially a business trip or something like that, is anybody expecting a baby this term? Nope. Okay, 'cause that's usually one of the ones that it's completely unexpected, and I'm reasonable about it. But if you tell me last second, oh hey, stuff got busy, it's like that's not sufficient. Tell me when you know something's a problem, and then we'll work on it there. If the assignments end up anything like my Android class, they're going to be a good amount of work, as you two can probably attest. Make sure you don't start them late. If you start them the weekend before they're due, you're probably not going to have time. So just make sure, the biggest problem when you start them late is trying to get a good understanding of what the assignment is. And it's really obvious to me, like the weekend before something's due, when I start getting emails like, what does this mean? What does this mean? It's like, you just started. I like to get that out as early as possible so you have time to get the assignment done and don't have to go through because sometimes the communication can take a little while. Okay, yes?
Are the assignments going to be due like on Monday night kind of thing, the day before, like the day of, or class?
Usually what I like to do for face-to-face is it's due the day of the class but a few hours before the class session. Because what I really don't want to have people do is skip the class so they can get the assignment done. So it's one of those things. I'll have to decide on that because since this is a 4:30 class, that makes it kind of early in the day that it's due. So I might have it due the night before, but I'll probably just make it due maybe like noon or 2 o'clock or something like that. And then that way it won't be I just need 5 more minutes, and then you end up spending half an hour, and then you're late for class. I'd rather people actually be in the class and see what's going on. Now that said, if you can't be here, I don't require you to be here. If you can't be here and if you need to, you can watch the videos when I post them, and catch up that way. The advantage to being here, obviously, is that you get to ask questions and you can really hear what the other students are saying when they have questions. Okay, any questions? Okay, that's the most fun part of the course out of the way right there. I should have, these slides. I should have made them, you know what? I am going to go over here and do that. That feels so much better. It's weird. It's like I'm binging Star Trek Voyager right now on Netflix, and SD shows, 4:3 cropped, and it's kind of grainy. It's kind of like, I can't believe we actually watched TV like that at one point in time. I mean, I can remember the transition from SD to HD, and everybody's like, why do you need that? And it's like, now I'm like, I never want to go back. Especially with 4K stuff now. 4K looks nice. Okay, so let's talk a little overview about what domain-specific languages are. Otherwise known as DSLs, which is probably what I'm going to say most of the time, because saying domain-specific languages is hard on my mouth. There's something about domain-specific, my mouth doesn't want to say it too well. These are typically little languages, sometimes that's what people call them. And if you think about breaking down the terms here, the domain is an area of expertise or knowledge. That's my definition of it. From dictionary.com, it's a field of action, thought, or influence. So think about stuff like science, math, programming, farming, teaching. It's an area where people have expertise. Because of that, there will typically be a certain amount of jargon and nomenclature associated with that domain. So if you have somebody from one domain talking to a person on a different domain, there's a lot of miscommunication that happens because of the terminology. If you think in terms of a specific domain, then you're tuning your language that you're using to the jargon and nomenclature of that specific domain. So domain specific, thinking in terms of that domain, communicating using that jargon or nomenclature. Does that make some sense? This makes a huge, huge difference. I mean, I'm sure you've all dealt with customers or sponsors who, and dealt isn't necessarily the right word because that sounds kind of negative, doesn't it? But you've interacted with sponsors or customers who they really know the domain really well. And maybe you as a programmer, you haven't learned it yet. Like 2 jobs ago, I was working for a government contractor, And I knew nothing about military logistics. And they dumped me into a program which was a military logistics program. And we were tracking things like, what tanks are on what base, things like that, which ships are in which ocean. And, coming up to speed on the domain took me a while. So there was a lot of miscommunication. I'd ask them questions and I wouldn't know the right way to word my questions. And so early on, I wasn't quite getting things the way that they wanted because I wasn't used to thinking in their terms yet. But once I got to that point where I understood the domain and I was able to use their language, their jargon, their nomenclature to communicate with them, things became a lot more effective. And what we're going to do as part of this class is deal with bringing in data from domain experts. So if we have somebody who knows a certain area, like a certain type of science, maybe it's some kind of the chemistry of IEDs or something like that, and you want to communicate with them and have them input data into your system. If we can come up with an effective format to structure that data for them, then they can just enter the data directly. And if we output data in that format, they can see and understand it much more readily. So that's interesting. I still have little languages at the top there. That's weird. This is what I get for doing slides at 2 in the morning. So some general uses of these. Usually you think of these as programmer-centric or user-centric. Those are kind of the two general areas of what you're going to use these for. For a programmer's point of view, you can use these to simplify your APIs. You can reduce a bunch of boilerplate code. You can combine them with code generation so that you don't have to type as much. And on top of that, when you have that boilerplate code that you have to type in every single time, chances are you're going to either have copy and paste errors or you're going to get it wrong at some point. Because you're going to have bugs in the same kind of code all over the place, maybe implementing it a little bit different everywhere. By generating that code, you make sure that what code you actually put into the system is very, very consistent from a very smaller specification. And that's where I like to use this a lot. I use it to generate models. I use it to generate forms in Android. And it makes my life so much easier. The main project I'm working on at APL right now, the code base is, I think it was about 110,000 lines right now. And 60,000 of that is generated. So that makes things a lot easier for me. The rest of that other 50,000 there, is code that I have some models written in little DSLs I've written to generate the rest of that code. And it's a huge savings for me. And it makes everything very, very consistent so that if I decide I want to change how something works, I go and tweak a couple lines in a code generator, and then 10,000 lines change across my project. It's beautiful. I absolutely love that. From a user standpoint, we can use this for that communication I mentioned with the users, where the users can specify their data in an easier format. You don't have everything in a spreadsheet anymore. You don't have everything in just raw documents. They have a structure that they can communicate with you, or XML. God forbid XML. I don't know if you've had people who aren't programmers dealing with XML. I should say aren't programmers and aren't web designers. If you're having people who aren't programmers and web designers use XML, you get some interesting results. It's just gross. XML is disgusting. JSON's not much better. I think JSON's a wee bit better. It's just a little bit less verbose, but it's very difficult to get that information specified. This actually moves your users closer to your code base. So what they're inputting, you're directly consuming, as opposed to coming up with some way to massage it. Like if you had a spreadsheet and you have to pull it in and then format it into your XML or do whatever with it. Instead, they're directly dealing with that data input. That's huge. There are two general categories of domain-specific languages. Now, Fowler listens. Is anybody who's got the book? You got a book there. Anyone else get the book yet? It is a really good book. He separates it into two general sections. The first section is narrative, so it's basically him talking about domain-specific languages. The second section is a reference, so it's much more of kind of like the design patterns books, or like his refactoring book, where he'll have the description of here's when you have this problem, here's what you want to do. And so it's very useful, reading through the narrative section to get a feel for what he's talking about. And most of the places in there, I agree with his approach on how he's thinking about domain-specific languages. I tend to generalize it a little bit more than he does. He has a fairly narrow field on it. But it's a very useful book in that sense, because if you want somebody else to help you on something, you can say, hey, go read this little reference section, and then they can get on board with what type of thing you're trying to do, or what you're trying to have them do. So he has a third section called language workbenches, which I'm also going to talk about. I just didn't put it on this slide because I wasn't thinking about it at the time. So there's really three general categories: internal DSLs, external DSLs, and language workbenches. So internal DSLs, this is you taking an existing language and using its features to make it look more like you're reading English, or whatever you're trying to have it do. So it makes a more fluent way of reading it. And there's several techniques I'm going to show you on this when we go through some of the examples. But basically, internal DSLs are using it inside a language itself. You're not using any external tools to do it. All of the specification that you're writing is actual code in whatever language you're using. Java is not a good language for this. I mean, Java you can do fluent APIs in, but when you want to try to start making things look more like a data specification, Java just falls apart for it. Kotlin's a good language for it. Ruby's a good language. I'm using Kotlin for a lot of my examples in this class. This usually depends very heavily on the types of language features that you have available to you. Whether you have extension methods on there, lambdas, whether you can pass in receivers to functions. Various features like that help you build up APIs, domain-specific language, internal DSLs much, much easier. The most common that you're going to see in this category are fluent APIs and builders. So fluent API is one where you have a sequence. Usually it's a chain of methods called. So you might have something that says when, open paren, some condition, dot, go to, open paren, something else. We'll see some examples of that when I go through the examples. Builders, very, very similar to fluent APIs. They're usually a subset of fluent APIs at that point. So it's a fluent API just for creating something. Now, external DSLs on the side, these are things that are completely independent of your code. Think of it as a brand new file where you're just writing some gibberish into. But the gibberish is only gibberish to the program. The gibberish is something that means something to you because you designed a language. So it's a completely independent from Java, Kotlin, whatever. And this code, you'll need some kind of a parser for. So you'll write a parser. The parser will be able to read that and understand it, and then create the appropriate data structures for you, run commands, whatever you want it to do. Okay. Think of it as just a separate file with a completely custom language. Now, language workbenches, he talks about them as something fairly new, and they're actually becoming more and more popular. Basically, it's a tool where you can define your DSL inside the tool itself, and it'll let you either graphically or textually manipulate the data behind the scenes, in certain formats. One of these is JetBrains MPS, and which Metaprogramming Studio, I want to say. I can't remember if I've ever looked up that name. I just always talked about it as MPS. But it's basically an environment where you can define a bunch of concepts, what data the concepts have, editors on top of those concepts, and then use that editor that you created to input data. I'm not very keen on MPS. It feels clunky to me because basically what you're doing is you are editing an abstract syntax tree of the data. Now, you, I'm sure, know what an abstract syntax tree is. Anybody else know what an abstract syntax tree is? A little bit of wishy-washy. So, general idea in an abstract syntax tree. Let's say you have a programming language like Java. In Java, there's stuff that matters and stuff that doesn't matter, right? Comments don't matter. White space doesn't matter, other than to separate the things that do matter, right? Everything else is syntax that you care about. So if you had a program in Java that you're writing up, or a class, you have your class definition. Inside the class definition, you have members, which can be variables, they can be methods, things like that, right? They can be other classes. Think about all those concepts as being represented as a tree. So you have a node at the top that says this is a class. Underneath that, he has a bunch of children, which are either variables, methods, or other classes. And then those have children inside of them. So maybe your variable has a node that's a name of the variable, a node that's a type reference. And then maybe your functions have a name, parameter list, return type, body. And then the body has a series of statements in it. So if you think about this as a tree, you can have your parser or your compiler take the code, throw out all the stuff that doesn't matter, grab all the pieces that do matter, and figure out how to represent them as nodes in that tree. You're creating this abstract syntax tree to represent what the user typed in. And you might be able to actually have the same abstract syntax tree for a bunch of different ways of writing the same code. Because the parser looks at it and says, this means the same thing as this, I'm just going to put it in this kind of a node here. Maybe the order doesn't matter in the abstract syntax tree, like, which order? Did you put your classes first or your variables first? Most languages it doesn't matter. Then you put that in your abstract syntax tree, and you can use that tree as a representation to do something. Now, MPS just keeps that tree in memory. It doesn't have a true textual representation. So what that means when you're editing is you can never have stuff that's invalid in the editor. So as you're typing, you have to fix every single little thing as you go along. It'll highlight it in red, and it doesn't actually add it to the tree until you fix it. And you have to tab between things to enter things. So it looks like code sometimes, but it really doesn't feel like code because the editor just has this clunkiness to it. So I'm not terribly keen on that. There's one that I'm going to show you called Xtext, which uses Eclipse under the covers. And I like the way that they do things a lot better than MPS, because you can actually define an entire IDE just by defining a grammar. And it makes it really, really cool. So how many people here know what a grammar is? Okay. And now, are you knowing grammar because of English or from a computer point of view? Yeah, they're very similar. They actually are very similar. I would hope from English. You all seem to speak English. So with a grammar, and these are concepts we're going to dig into a lot deeper later on in the course, by the way. A grammar just describes the structure of your language. And the grammar is just a syntax-based representation of it. It tells you what is valid to type. It doesn't do the semantic checking on it. So the semantic checking is when you try to say, okay, structurally this looks good, right? But what does it mean? It's the semantic part of it. And so you'll figure out those semantics and represent something based on it. Well, Xtext is a very smart representation where your grammar defines your data representation and then creates a model for you automatically. And then you can easily walk that model to figure out what to generate for your code or what to execute if you're doing it as an interpreter. And we'll see some examples of that. Code generation. As I mentioned, this happens quite a good bit. I use it a lot. And I think this is, I don't want to say holy grail because there is no such thing, but this is something that can really, really reduce your coding time quite a bit. There was a friend of mine when I got on the project I'm on now, 4 years ago I think it was. He was the lead for it, and he was working on the models for this thing. And he had about 40 model classes he was dealing with, and he called me and he said, hey, I want to set this up now so that these things report when they're changed. And he says, what's the best way to do that? And I said, well, here's what you're going to want to do. And I said, but you're going to have to do that in every one of your setters in every one of these classes and do it the same way. And if you decide to change that again at some point, maybe adding some extra logging or maybe changing the way you're reporting things, you're going to have to go and change every one of those setters and that. And so I talked to him about code generation. And I said, I can set you up a little model here that will generate all that crap for you. And then if you want to change the way things get reported, you change it in your code generator. So it's like a 5-line change versus 5 lines in every single one of your classes there. And at first, he got a little confused by it. And this is one of the things that happens with DSLs, is it's a fairly foreign concept to most programmers. It's one of these things that's been around for a very long time, but for some reason it just hasn't been really incorporated into kind of the natural flow of what programmers understand and know. And that's one of the reasons why I wanted to have this course, because I wanted to try to get the word out that this is a very useful tool. And it is a tool. It's not something you want to use everywhere. But when you have a situation like that, spending a half a day to write a little model generator that generates all that stuff, the first few weeks, he was just kind of a little getting his head around the flow of the build, how it worked. Because you edit your model, the model gets compiled into the generated code, then the generated code gets compiled by the Java compiler. After a little while, it's like, at first he was kind of like, well, why are we doing all this extra stuff? We don't need this. until the first time he needed to do that next change. And then when he needed to do that next change, he's like, oh, holy crap, this is incredible. And anytime he needed to change his model or add new model classes, boom, tons of stuff edited for almost no cost at all. Again, it's not the silver bullet for every single thing in the world, but if you find yourself where you have a whole bunch of things, you have to make the same change in a bunch of places, and there's a decent chance it's going to keep going on like that, consider it. So the idea here is we read the DSL in, and we write source code based off of it. And you use this fairly oftenly with DSL. Generally with DSLs, you're either going to read things in at runtime from the DSL, or read them in at build time and generate code, which just runs at runtime. This moves your error checking to build time. This is one of the things I really like about this, because normally if you read in a file that has your data in it at runtime, you can't report the errors anyplace other than runtime, unless you have some additional validation tool at build time for that data. Now, of course, the problem there is if we do stuff at build time, we have no opportunity to change it at runtime, right? So there's your trade-off. If you have a data file, it's always going to be the same. So the forms that I use for the application I'm working on right now, I have those forms specified in a DSL, and they generate XML in Android, they generate binding code for Android, they generate some model information, they generate a bunch of skeleton methods that I can fill in later, and they don't change very often. So they don't have to change at runtime especially. If we need to add a new field, it's something that has to go through the software process anyway. So doing it at build time is fine. But if we wanted the forms to be truly dynamic, so if we wanted somebody on a server to put a form up there and we would download it, you have no choice but to do it at runtime. So that's one of those cases where code generation isn't going to really help you there, at least for defining the forms. Does that make sense? Okay. So generating the code, often you get better performance out of it, because parsing a file tends to be fairly expensive, especially if your language for that DSL is fairly complex. Just the file I.O. of reading it in, and then understanding it and creating objects. A lot of times there's a lot of intermediate objects that have to be created during that. So that can be fairly expensive. But again, if you change that DSL, if you need to change the data that's inside of it, you need to do a rebuild. So that's your main point you have to consider with code generation is this something that needs to change at runtime or not? Now, chances are really good. I'm not even going to say chances are. I'm going to say definitely you have already used DSLs. And the first bullet on this, if it's the one I remember. Okay, it's not the one I remember. Math. When you write equations in math, that is a domain-specific language. Think about it. It's the way that mathematicians use to communicate mathematical concepts. And when we learn this in school, we can now communicate with math people. We understand it. We read a book, we see an equation, boom, you understand what is going on. Until you start to get into things with, fancy calculus, and it's like you decided to pull that out of your brain long, long, long ago, after you decided not to become a math teacher and you wanted to become a programmer instead, like me. But math is probably the most common DSL that pretty much everybody on the planet has used. And if you think about it, 1 + 1 = 2. Everybody on the planet has probably seen that, or pretty close to it, if they've seen math at all. The next one, if it's what I think it is one that's near and dear to you, and Martin Fowler probably would not agree with me on this one. I look at domain-specific languages as being languages for a specific domain for being used, right? So programming languages fit in there. It's a type of language for doing a specific type of task, communicate in a certain way. I think that fits in there. He doesn't agree with that one, but he likes to think of them as very, very narrowly scoped, and I can understand where he's coming from. But I think it's useful to think about this because it's a type of language you've developed to communicate with a computer and make it do something. The computer is your target audience on that, so it works pretty well there. Build tools. Make, Ant, Gradle, things like those. Make, if you take a look at it, you're like, yeah, that's not a normal computer language, right? But it is a language, it has certain types of rules for doing a specific type of thing. Ant feels a little weird because it's in XML, but think about the specific implementation of that XML. I mean, it's a specific XML implementation for doing builds, things like that. Gradle is a little bit more obvious. Groovy is a great language to write DSLs in, because if you look at Gradle, it looks kind of like a data specification more than anything. But one of the nice advantages to Gradle, that's an internal DSL inside Groovy, you can actually use Groovy language constructs in there. So it's a full-up Turing complete language. You know, not only are you using it for the build constructs, but you can add to it. And that's fantastic there. And unfortunately, you have to have external Java code that you've written to be able to extend it and add new tasks and things. XML and HTML. XML itself is a language for defining other languages. Okay. HTML is one of those other languages, very similar to ANT. And HTML is another one that lots and lots of people have used, and they don't even really realize it really is a DSL. It's a way of communicating with a browser in this case. Squeal, very common one. And yes, I said squeal. That is the proper way to pronounce those three letters. At least that's what I learned at IBM. When I was there, they kept saying it's pronounced squeal. When I told them sequel, they're like, no, squeal. And I'm like, why? And they said it's one syllable versus two. So it's faster. Until you have to explain to somebody what it means, and then it's slower. It's the first time. But now when you hear me say squeal again, you'll know what I'm talking about. Regular expressions. Another little domain-specific language, and that's a great way of, think about the code you would have had to write to do most regular expression type work. I mean, I have written code like that before, and it's not pretty. It's very unpleasant, but it's doable. And if you have a language that supports regular expressions, it knocks that down a lot. Or if you have a library that does all that code, it'll knock that down a lot. UML. Note that this one's graphical. Nobody ever said that DSLs have to be textual. We can represent things as a picture. And sometimes pictures are a really good way to represent things. We're going to be going through Fowler's example using the state machine definition. We're not going to do the graphical side of it. I didn't have time to come up with an example for that, but I'd like to at some point. But think about state machines. Graphical representation of state machines is really the way to go. I mean, it's, depending on what you have to do inside of it. I mean, the state machine stuff we do. I work with John. The stuff that we do for Mantis, the state machine definition, and that one's all textual, but there's a lot of stuff going on there. Dot. Has anybody here ever used GraphViz? Yeah. Isn't that a great tool? I mean, it doesn't produce the prettiest looking diagrams ever, but it's crazy useful. This is a tool that AT&T came up with, and you use a little language called dot to specify a directed graph. And you can draw state machines on the screen. I mean, even for our thing, I actually have it producing dot output, so you can dump it and get a diagram of the state machine. You probably didn't know it does that, did you? It's like if you look in the logcat, you'll see it there. It's like, oh, wow. Then you can just copy it, paste it into something to view dot, and boom. But GraphViz, if you ever need to draw a directed graph, that's a fantastic tool, because you basically just say A, arrow B, B, arrow C, C, arrow A, and it'll draw your little diagram for you. LaTeX. This is for creating documents textually. There was one that I used to work with a long time ago called Bookmaster at IBM, which was kind of like HTML before HTML came out, and similar to LaTeX in some ways. So some common tools that are out there for doing these types of things. First of all, programming languages. A lot of programming languages you can implement the DSLs internally. Whether you're doing fluent APIs, whether you're doing a more natural feeling DSL out of it. Different libraries. Maybe you have an XML parsing library. These are tools that'll help you parse common formats of things. Parser generators, things like Antler, or Lex, and Yak. I was really impressed when I was doing the Android class. There's a module where I talk about Antler, Lex, and Yak, and I don't spell them out in slides. I just talk about them. And we sent the video to 3Media to do captioning. When it came back, Antler was spelled A-N-T-L-R, Lex was spelled L-E-X, and Yak was spelled L-Y-A-C-C. And I looked at the result there. I'm like, this person knows the domain. I mean, I was shocked, because that's usually the problem with captioning, is you send it off, and homonyms are a nightmare. I mean, the best one I got was one where I was talking about a class cast problem, and cast came back C-A-S-T-E. And I totally can understand, because it's like, somebody who doesn't know the domain, they have to pick some spelling of it. But this person who came out with Antler, Lex, and Yak, I was like floored. I mean, and the transcription of it was pretty much flawless. I mean, I had to do the least editing on that one of anyone that I got back. And I sent a note to 3 Media and said, hey, whoever did this one, kudos to them. I mean, honestly, I don't know why they're doing transcription for a living. I mean, if they're aware of the domain, maybe they couldn't cut it in a domain. I don't know, or they're just doing it for extra money on the side. But I was impressed. Language workbenches, things like MPS or Xtext or things like that. Various tools that really make your life a lot easier with these things. Okay, any questions so far? Oh, I did change that. I'm like, what did I change? I made it bigger. Speaking of making it bigger, I should probably fix up my font sizes on here, because I don't want anybody in here to go blind. Let me go a little bit bigger. Let's go 28. And let's see. Is that readable? Okay. Yeah, if anybody has any problems with it, I don't want anybody to have eye issues. Okay. So let's see. It is 5:30. Wow, that went a little bit faster than I thought for the first part there. You want me to keep going, or you want me to take a break? Break? Let's take a break. Let's take 10 minutes, and we'll say at, what is that, 5:47, something like that? Okay, so it's time to dive into an example here. Now, in the DSL book, Fowler has this thing he calls the Gothic Security DSL. And the idea with Gothic Security is that if you remember, like from old movies, you have these castles that have all these secret passages and little switches to make things happen. The idea here is that there's this company called Gothic Security, and they have set it up so that when you hire them, they will put a secret panel in your house somewhere and let you define how you want to trigger it. So it might be triggered by, closing a door, turning a light on 3 times, opening a drawer, and then the panel opens. Or it might be defined as, walking into a room, pulling the shades, knocking on a cabinet 3 times, and then opening a window. I don't know, something like that. The idea is that every client might want it differently, because every client's configuration might be different. The example that we're going to look at here is somebody walks into the bedroom, closes the door, opens a drawer, turns the light on, and then the panel opens. Or they walk in, close the door, open the drawer. Actually, no, turn the light on, then open the drawer. So whichever order there, doesn't really matter. Just make sure it's recording. Good. Okay, so this little example, basically we're defining a state machine. And we want to define that in a couple different ways. We're going to first of all start with a completely brute force, kind of brain deadish definition of things. So I'm going to take a look at this, and this is written in Kotlin. I'll talk a little bit about Kotlin here and there, kind of describing some things. Anybody here used Kotlin before? I know you've used some. Okay, Kotlin is a really cool little language. Think of it as basically taking a lot of the good stuff of C++, C# and pulling it into Java, and then fixing the syntax a little bit. Really nice little language. It's being pushed pretty hard with Android development right now, so if you do Android development, this is a great way to do things. I'll describe each of these as I'm going through. If you have questions on what something means, please point it out to me. But a lot of this is going to kind of be trial by fire hose. Is that the way to say? So I'm going to dump a lot of stuff on you here. But if you have questions along the way, let me know. Okay. The assignments, some of them will definitely be in Kotlin. Others, you could do Java or Kotlin. Just kind of depends on what the assignment is. I mean, if we're doing internal DSLs, it's going to be Kotlin or Ruby, depending on what I do for that assignment. Okay. Has anybody here ever done Ruby? Okay, so we have a couple of Ruby. I have not done Ruby. So I'm planning on learning Ruby and hopefully using it for some of the examples in the course at least. I've heard it's interesting. But Kotlin's actually pretty easy to learn. Everybody here knows Java, right? Okay, good. Enthusiastic nods are always a good thing. Sometimes I get people kind of like, yeah, it's like JavaScript, right? I'm like, it shares 4 things with JavaScript. the first 4 letters of its name. Okay, so Kotlin runs on the Java virtual machine. It can actually run in JavaScript as well. And I believe that there's a port of it for iOS that they're working on right now too. So this is a language that hopefully we'll be able to use all over the place, because I love it to death. There's a couple weird things in it that aren't the best thing in the world, because it was created by JetBrains, the people who did IntelliJ, and IntelliJ is a hot mess, so there's going to be some things that leak over into this. But in general, it's a pretty darn good language. I'm going to go through constructs in here, hit you with them. We'll figure it out as we go. So start off with a package declaration. You'll notice there's no semicolons in Kotlin. It's similar to Java without semicolons in many places. I'm going to define an abstract class here. All classes in Kotlin and all functions in Kotlin are public by default. Okay. I'm okay with that. What drives me nuts is that all classes and all functions are final by default. So if you want something to be extensible, you have to explicitly put the word open or abstract in front of it. If it's abstract, it's automatically open, so it's non-final, because duh, if it's an abstract class, it doesn't make sense to make it final. If it just says class command there, that sucker's final. You can't extend it unless I put the word open in front of it, like that. So weird little thing in there. They're taking it from the point of view of, I think they got that from Josh Block in his Effective Java book, which is like you should explicitly design for extensibility rather than just let people willy-nilly. So basically everything should be final by default. I don't agree with that. I'm very much in the other camp of everything should be open unless there's a real good reason not to. And usually that real good reason revolves around security at some point. But otherwise, hey, if I have a class and I want to extend it, let me. Of course, this code is guilty of that, right? Because everything's final, so nobody can extend anything. So we're starting off with this idea of an abstract event. In his little state machine, he has commands and he has events. A command is something you're going to send to a device to make it do something. So in this case, lock a door or unlock the secret panel, those types of commands. An event is what the user did. So like opening a drawer or turning a light on, things like that. And there's going to be a controller in the room, which is probably just going to be, a little Google Home device or something like that now. But the controller is going to be the thing that gets these events coming from what the user messed around with and sends the commands to devices. Okay. It uses the state machine to figure out what to do with that. Now, each command and event has a name and a code. The code gets sent to the devices because we're going to assume these devices are maybe like little Raspberry Pi devices, so they're fairly minimal, don't have a lot of memory, but they can do some things. We're going to ship over some simple commands to them. A state represents what we're currently thinking of in the state machine. So what's been done so far. So a door has been opened, a door has been closed, things like that. And a state machine manages all that stuff together. Now my structure here is a little bit different than his structure. And it's actually going to change from example to accommodate whatever the example is doing. But it has the same general idea of what's going on there. So we'll see here, here's an abstract class. You're going to notice that I have no body on this class, right? In Kotlin, if all you got is data and you want that data passed to a constructor, you can just go ahead and throw the data in the constructor directly just by putting the word val in front of it. Val means it's a not mutable property. It's immutable. Cannot change it. Var means that you can change it. Basically what that boils down to in Kotlin is, does it have a getter, does it have a setter? So vals have getters, vars also have setters. Okay. You won't say set something in Kotlin, you'll just reference the property. So say x.property_name equals something, or something equals x.property_name. Okay. This is extension. So command extends abstract event. And you'll see here that I'm passing in name and code. They're not listed as vals. They're just passed in as constructor parameters and getting passed to the superclass, who defines them as vals. So the superclass is defining those two properties, name and code. And I'm just passing the data through here. And I'll do the same thing for this event class down here. The state class here, I have a couple vals. Note that I'm not passing them in a constructor. So when I create state, I'm not going to have any arguments in that constructor for him. I'm going to have a mutable list of actions, an immutable map of transitions. The list of actions are these command objects. So for a given state, once I enter that state, what actions occur? So if I enter a state that ends up unlocking the panel, it's going to say lock the door and unlock the panel. Transitions are how I get to different states. So when I see a certain event, what's my next state that's happening there? Now he actually had a separate transition object. I didn't think it added anything to this situation. I thought just having that map was good enough there. So there's my state class. Now when I say val actions, it means actions is a pointer to a mutable list here. Note that it's a mutable list, so I can go to that actions and change what's inside the list. I just can't make actions point somewhere else. That's the difference of the mutability in this case. Okay, make sense? If I said var, then I could come in and say actions equals something else and point it to a completely different list, which I don't want to do in this case. Now my state machine here, I'm coming in with a start state. Note that I made it a private val. So this means that it's a property, but it's only used inside the class. By default, they're public. Okay. Inside here, notice that I have some little helpers. Well, first of all, I have reset events. This is a set of events that what's going to completely reset my state machine. He decided to take a shortcut so that there's certain events, like if somebody's in the room doing things and then opens the door, it completely resets the state machine. So they have to start over. It's a little security measure. And he wanted to set that up so that instead of having to define that transition in every single state, which you could do, he would just define an explicit set of reset events. So if an event comes in and it's a reset event, boom, go back to the start state. Then I have these two helpers here, all events and all states. These are maps so that I can look up events and states. One thing that's tricky with this model and with this scenario is that I need to have forward references. So each state is going to define a set of transitions to other states. You can have circular references between them. So a state defined up here could reference a state defined later and vice versa. So we need to be able to keep track of what those states are up front and then do resolution on them. And we'll see how that works in later examples. The first example, it's really explicit, so we can set the order however we want to. But in later examples, we're going to want to set it up so that we can define the states and the transitions together and then have a resolution step afterwards. If you are used to compilers, this is also known as a second pass. So we're going to take another pass through. The first pass just defines things. The second pass does the linking. I have a couple helper methods here to assist in that so that somebody on the outside can say, give me the event for a certain name. And then it looks it up in the hash table. Now this is where the syntax gets a little fun, right? Let's look at these guys first. Reset events equals mutable set of paren paren. So it's going to run this mutable set function to create a mutable set. In Kotlin you have, if you just say something's a set, it doesn't have an add method. If you say it's a mutable set, it does have an add, it does have a remove. Down here, this guy, all events, is a hash map, right? Where he's a map. To reference things in the hash map, I could say all events.get, but the preferred syntax is all events bracket. And that just calls the getter under the covers. It actually ends up that this bracket syntax calls a method called get under the covers. And you can overload that operator yourself to put the bracket functions in your class. The bang bang over here means I know it's not null. You're telling that to the compiler. If I didn't say that, the compiler is going to complain that when the guy calls this, that all events might be returning a null. Because when you go to a hash map, it might not be there. Now, this bang bang is not a good idea. I'm just doing this example to keep the error processing out of the picture here and make the example very simple. This means that all my test cases have to be perfect. Otherwise, I'm going to get an exception thrown. So the bang bang is your way of saying, trust me, Kotlin, this is not null. There's going to be cases where you use that's valid, otherwise not. When you're defining a variable, like these guys up here, var name and code, these are non-null. If I throw a question mark on there, that's telling Kotlin that can be null. If you don't have a question mark, you cannot pass a null in there. Make sense? And then when you reference it, will it get that null or not? So nullability checking in Kotlin is really well done. I mean, it flows through very well. You know, you're explicitly saying null or not null. Okay. These functions, you'll notice that they don't look like they have a body. If you just have a single expression that runs the function, you can say equals, and then that single expression, as opposed to having the curly braces. But I could still have said curly braces and inside there said return all events name bang bang. Reset target. This one here is saying if reset events contains the event that's coming in, I'm going to call the start state. Otherwise, I'm going to return null. Now notice that this if statement here is returning a value. It's not really an if statement, it's an if expression. So the equivalent of this in the curly brace form would be that. But I'd have to also up here say state question mark. So that's really the equivalent of what that equals version was. A little bit more verbose. Looks weird to have return if, doesn't it? It's something you get used to after a little while. Okay, but I prefer the other format of it. Oops. So the return type is implied like that. Something like that. Make sense? Okay. Now some of the syntax is going to look weird. Wait till we get to streams and things like that, then it looks really weird. Some of it's very functional, more like a functional language. Okay. Now a command channel, this is where you're going to send the events to make it do things. And all we're doing here is printing them out to simulate the fact that it went to some device and made a light turn on or made a panel open or something like that. Our controller is the little Google Home thing that sits in the middle, managing all these things coming from all over. So he's going to keep track of a start state that comes in there, the state machine that we want to use, and the command channel we want to send commands to. And he's going to be the one we ask to handle events. So whenever somebody opens a drawer or turns a light on, it goes through this handle. And we're going to look at this guy and say, okay, we got an event coming in. You'll notice that the declarations of the variables are reversed. Variable name : type instead of type variable name. Maybe the people who wrote this language preferred Pascal's way of doing things, which is you have the name : type. Doesn't really matter to me either way. It's just a problem when I switch back and forth between Kotlin and Java, remembering which one is which, because I'll start typing the wrong thing each time. So what I'm going to do in here is I'm going to say, let me figure out what my next state is. So I'm going to take a look at the current state, grab his transitions. That's a map. I'm going to look up that event in the map. Now note that that might return null, right? That's where Elvis comes in handy here. That's the Elvis operator. And if you turn your head sideways, it does kind of look like Elvis, with his hair and then his eyes underneath his hair. That's why they call it the Elvis operator. Elvis operator says, if this side is non-null, that's the answer. Otherwise, use what's on the other side. So we're going to use this side here, state machine reset target. So this is going to say that reset target method takes a look at the event and says, if it's one of my reset events, return my start state. Otherwise, null. So that's going to set my next state. Now, this, the way I've written this right now is very dangerous because, again, I'm not doing the error checking on this to make sure my model's okay. So I could end up with a null there, which would not be a good thing. Now this next block here, I'm using the let function in Kotlin. And what that does is it says, take whatever my receiver is, the thing that called let, and pass it in as it. This is to a lambda here. So we have a little lambda, which is going to execute some code. And the default parameter name coming into the lambda is it. I could rename that. I could say state arrow and then say state there. And that would work just fine. But if you only have one parameter going into the lambda, you don't have to name it. You can just use it implicitly. Just like that. Whoops. Okay. So what this is doing is this is saying, let me evaluate next state. It may or may not be null, right? So this question mark dot says, if it's null, stop there. Don't keep going. If it is not null, keep going. And so the let is going to take that non-null value and pass it in. Note that the it here says state without a question mark on it, right? So that means it's not nullable. If I did this, note that that state changes to a question mark on the end, saying it's nullable. So this is an idiom that you're going to see in Kotlin a lot. this something question mark dot let, which is kind of equivalent to if next state is not equal to null, do the stuff that's in this block. But there's one big advantage to this. If next state were something that was a property that's mutable in some other object, it can change in a different thread at the same time I'm doing my checks, right? So if I had an if statement that says if it's not null, and then inside the block, I'm assuming it's not null, right? Another thread could go and change it. And in fact, Kotlin will actually catch that type of problem. In this case, it's a local variable, so it's not an issue. But if next state were a property in some other object that's potentially nullable, checking it outside the if and then operating on it inside, there's no guarantee. And so Kotlin will yell at me. That's one of the places let is nice because it takes the value at the point of the let and copies it into that it variable.
Takes the value of the pointer, right?
Right.
Not the actual underlying object.
Exactly. Yeah, it does. It just does a pointer copy. Okay. So what I'm doing in here is if the next state that came back from here is not null, then I'm going to change my current state and then execute each of the actions. So here I'm saying take that current state, find his list of actions. For each one of those, I'm going to do that lambda. And so that I'm just going to go to the command channel and send whatever that action is to the command channel. Command channel will then print it. Make some sense? By the end of this course, you're all going to be real comfortable with Kotlin. It's actually a pretty easy language to learn. Okay, and if you have any questions along the way, feel free to jump in, ask me, send an email, send a discussion forum preferred, of course. Okay, so there's our model. It's a fairly simple little model. Now using it, we can use it in a real brute force manner like this. And this is basically a copy of what his first example was. His first example is in Java, but I've converted it to Kotlin here. So what I'm doing here in Kotlin, companion object, you know how in Java you can have static functions and static variables, static methods, static variables, and main is a static method. There's no statics in Kotlin. But you can have this thing called a companion object. And think of this as the metadata for a class has a little object kind of hanging off of it. It's just riding along all the time. And it's that single instance of that object that always floats along with it. So if I went to the class, I can say, hey, test1, give me your companion, and I'll talk to him. And then I'm always talking to the same object. Any functions in that companion object are always working on the same data. Any data, it's just that one copy of the data for all instances of that test class. Does that make sense? So think of them as basically statics. They don't get translated into statics in Java, which is why you can say explicitly, I want this to be a static method in Java when it creates the Java code. For the main method, if you want to actually run it as a main, you got to do this. Or define your main method outside of the class. You can actually define functions outside of classes in Kotlin. Be careful about that because it adds to your namespace for everything in that package. So if you define the same function in multiple files, you'll have problems that way. So I usually prefer to try to keep things inside companion objects if I just want a single copy of them. So in here, I'm just having my main method, and he just does everything. So he's going to set up the data and run the tests. So for configuration, the first thing I'm going to do is set up a bunch of event objects. When you create an object in Kotlin, there's no new operator. You just say the name of the constructor, passing in the data. So I'm creating all these events for door opened, drawer opened, light on, door opened, and panel closed. Door closed was the first one there. So here's my different events that can happen in the system. Then I'm going to define the commands that I'm going to send to that command stream. Unlocking the panel, locking the door, and unlocking the door. So those are the only things that the system is going to do to things, is lock or unlock doors and panels. Then I'm going to define my states. Now in his example, he actually passes a name to the state. I can't remember why I removed them. They weren't being used anywhere, so I removed them, and I look at this and it looks kind of funky. It's like, oh, there's just these empty state objects. But these are going to have the transitions and actions added to them a little bit later. So this is kind of my two-pass thing I was talking about. I create the states, and then I configure them after they've all been created. Create my state machine here with the idle state as the initial state that it goes into. And then I'm going to set up each of the states. So the idle state, I'm going to say from there, once you close the door, you go to active. So the idea is you walk into your bedroom, close the door, boom, it's on. Things are getting ready to go. At that point, when I get idle, I'm going to unlock the door, or if somebody comes into the idle state, so if we reset, we unlock the door and lock the panel. So that's basically what happens on a reset. When I'm in my active state, there's two things I can do: open the drawer or turn the light on. And then I put them into those states, waiting for light or waiting for drawer. So I do one thing, I'm waiting for the other. If I'm waiting for light and I get a light on, I'm going to go to the unlock state. If I'm waiting for the drawer and get the drawer opened, I go to the unlock state. When I'm in the unlock state, the two things I do are unlock the panel, so it pops open, and lock the door so nobody can sneak in and see me, getting my jewels out of the safe. To get out of there, if the user closes the door, I'm done with the whole thing. So I restart the system, going back to the idle state. Make sense? So this is a very brute force setup here. Finally, I add a reset event of door open. So if at any point during this system the door gets opened, I go back to my idle state again. So here's my test run. I'm going to create a controller starting in the idle state, have my machine, and have my command channel, and then run some tests here. So test 1 is going to close the door, open the drawer, turn the light on, and then close the panel, and we'll see what happens with each of those steps. Test 2 swaps the order of the drawer and the light. Test 3 is opening the door right after I close the door, so it should reset the state machine. Test 4 goes a little further. I turn the light on, and then I open the door. And test 5, I get to the point where I'm interacting with, the safe panel is opened up, and I open the door, and it should shut everything down. So let's try running this. I have this example set up using Gradle. Setting up Gradle in IntelliJ was not pleasant. I mean, it's easy in Android Studio because it does everything for you, but some of the tools that say it's creating a Gradle project don't do everything they're supposed to do. So I had to do a few manual things. When you check this when you grab this project, it'll work for you because it's already configured. But when I get into other examples, I'm going to walk through with you guys how to set this thing up so that you won't have trouble with it. So the Gradle build that I have here has a bunch of little extra tasks I added in to run each of the tests. So I'm going to run DSL test 1, DSL test 2, and so on. So test 1 is the first one I'm going to run here. This is going to build everything and then run it. This is going to build everything and run it. There we go. So let's take a look at our output on this. So he built all of our wonderful stuff here. This generated grammar source. That's for the Antler example I'm going to show you in a little bit. So we're going to start off the first test. We're sending out the commands unlock panel and lock door. So this is when we got to the final state of everything's fine. Then I said close the panel, which unlocked the door and locked the panel. So it sent out those commands. Test 2, same kind of thing, except I reversed those two steps in between. So I'm seeing the exact same output because I got to that final state, and then I closed the panel. Test 3, I aborted, so it ends up going back to the start state, the initial state. The idle state ends up unlocking the door and locking the panel again. This one aborted as well. This one got a little farther, so I got as far as the panel popped open, but then I opened the door, and so it's immediately shut things down. Make sense? So this ended up running successfully. We did everything brute force. Wow, how exciting that was, right? Let's take a look at another way to do this. So this time, I'm going to use XML to configure this system. Because it seems like, why should I have to write code every single time I'm going to deliver a new machine? I could, but we might as well just throw this in an XML configuration. So here we defined XML, and this is pretty much a straight copy from what Fowler has in the book. In this case, I'm defining my state machine with a start state. Everything here is string-based. Think of what happens if I make any typos in this file. And trust me, when I was writing this example up, I made plenty of typos. So there's a lot of run, tweak, run, tweak, run, tweak, do, run, tweak, do, and then finally I got it running. So everything in here now works. So I define all my events, define all my commands, and then for each state, I'm saying, here's my transitions, here's my actions. Notice that these are using forward declarations. but these forward declarations are string-based. So what I had to do when I'm configuring this in the XML is set up the states and then run a second pass through them to resolve the transitions appropriately. Okay, and then finally down here I have a reset event for door opened. This goes through this XML configurator. I never know what to call these things. Somebody came up with the name configurator at some point, and it seems like the right word to use. It's not a real word as far as I know, but it kind of sounds right. I don't know, whatever else, configurer or something like that might be the way to do it. So to configure to configure this thing, I knew that was going to happen. I'm going to have this configure method here. So basically on the outside, somebody's going to say, create an XML configurator, passing in the name of the file, and then run this configure method. So here I'm creating some helpers. These guys are going to hold on to the events, the commands, and the states. So as I'm creating them, I hold on to them. Then we're going to later push them into the state machine. Then I'm going to use DOM, which I made the horrible mistake of using DOM for this, but it's in the JDK, so I didn't have to bring in any extra dependencies, and I wanted to try to keep this as dependency-free as possible. I ended up pulling in dependencies for Antler, but when I did this example, I was thinking, you know, I'd rather use JDOM because it's so much cleaner. But and man, after I did this one, I was like, never again. I'm never going to use DOM again. Yes?
Why is that?
You'll see in a second here. It's gross. I mean, the API on DOM is absolutely disgusting. JDOM fixes it by making everything be collections. So when you say, give me the children as a collection, in DOM, you have to do things like this, event nodes item 1 or item I. So you can't iterate on things. It's really just absolutely disgusting.
It doesn't matter for this, but doesn't DOM read the entire
yes.
document at one time?
Yeah. The big difference, when you're doing XML, if you anticipate a small XML document, it's okay to use DOM because it reads it all into memory. If you're anticipating it, you don't know how big it is, or it could be huge, you're going to want to use a streaming type API. So you can use either SACs for it or stacks, depending on if you want it to be pushed into you or you pull it as you're reading things. So you have a choice on that, but generally you want to use more of a streaming API. I use this to my goal was to try to keep it simple, and it got gross fast. And it was one of those points where I'm like, do I change it at this point or just keep going? And I kept going. Maybe I shouldn't have, but I kept going. I persisted. So I'm doing all the DOM setup here. I'm going to find the root document. I'm going to get the start state name off of him, grab my nodes, the event nodes, command nodes, and state nodes so that I can walk through them. For my event nodes, I'm going to pull the data off and create event objects and put them into this event map up here. Command nodes, same thing. Pass 1 over the states. All I'm doing is registering. I'm just creating the objects and registering. So state subname equals state here. I'm just creating those new state objects. And then I take a second pass to do the transitions. So in this pass, I'm then going to look at the child nodes and see what those child nodes are. So the child nodes, I say, look at each one of them. If his node name is transition, create a transition object and set it up. I'm sticking it actually in the state, so I'm saying my state I'm assuming is non-null. Grab his transitions array. I'm going to look up events from that little temporary map. Bang, bang, I'm assuming it's non-null. Lots of assumptions here which are very dangerous, but again, simple example. And then set that to be that specific target state. Gross, huh? I mean, DOM does not help here. I mean, it's just, what I'm doing here, I'm trying to keep it fairly simple and compact, so it's a little bit gross to start with, but DOM really made it extra gross. Then I'm going to create my state machine, passing in that start name. So I'm going to take the start name, look up the state for it. I couldn't do it till this point because I had to make sure I read all my states in first. And then, for each of the events, I'm going to put them in the state machine so that he keeps track of things, so people can look them up later. My reset nodes, I'm going to find all those, and for each of the resets, I'm going to add it to reset events. So all my configuration is being done by the XML getting sucked in and read here. So this is example 2. Going to run test 2, and surprise, surprise, it works because I did this before class and made sure. Some examples I'm going to do live in front of you. One of the things I like to do, and you get mixed reviews out of the students, is I like to to write code on the fly in class. Part of the reason for that is because things don't always go perfectly, and when they don't go perfectly for me, I like you to see how to get out of the error. So it kind of helps that way. It also makes me seem like less of a god, because I can make mistakes. It's okay. But I'm a demigod. Okay, so I'm like Kratos. So a lot of people caught that reference. That last game, has anybody played the new God of War? It's good. There's a couple points I really wanted to reach to the TV screen and just strangle the kid. I mean, there were a couple points. And if you play the game, when you hit those points, you will know exactly what I meant. Okay, everything worked just fine here. Build executed in 0 seconds. Wow, that was fast. Okay, questions so far? So those are 2 ways of approaching this problem. Okay. I don't like XML. I despise XML. I think it's gross. There are much, much better ways to do this. So what we're going to do to start with is I'm going to back off from the external file, and we're going to come back into internal and try to use some internal DSL techniques. The first couple we're going to look at are basically just going to be making things look a little nicer, but I don't think quite hit where the internal DSL level is. But they'll be more readable, so it's more of a fluent API approach. So let's take a look in package DSL2. I'm not sure why I didn't split the first one into 2 different packages, but hey, it happens. This one, I've changed things to use constructors to do all of our setup, so that hopefully when we create this, we can see something that looks more like a tree defining the data, which really gives you a visual indication of how these things are associated with each other, because certain things are inside other things. Now what this means is a lot of that extra setup stuff we did in the XML, those extra maps, have to get pushed inside the state machine. Because he's getting past stuff as a constructor, he needs to hold on to things temporarily and then resolve them once he's done. So some of this is the same, like these guys haven't changed here for the abstract event. The state, he ends up with a new method in here called resolve. And what this guy does is I'm going to pass in the state machine so I have access to those maps of this event is this name, or this name is this event, and this name is this state. And I'm going to walk through all my transition specs. Note that they come in here as strings. So the action names that come in are just a list of strings. The transition specs are just a map of strings. And I'm going to walk through that transition spec up there. And for each of them, it's going to give me a map entry from string to string. I'm going to get the key and get the value off of those, look them up in the little maps that I keep track of in my state machine, bang them because I'm assuming, again, that everything is perfectly fine. Really bad idea in real life, but for this example, it works and keeps things a little simpler. And then say transitions sub certain event equals the specific state that's the target. So I'm just associating that. I do something similar for action names. For each of those action names that comes in, I'm going to take it, look it up in my in my map of commands that I'm keeping track of in my state machine, and then add that as an action. So this is my resolution step, the second pass. Okay. Some people might call that a linking step instead of resolution step. I tend to avoid the word linking unless I'm really getting into a compiler situation. So, if you're thinking linking, it's perfectly fine to think that. I just tend not to associate that word unless I'm really doing a very specific compiler type thing. So here's my state machine. So inside here, I have the list of commands coming in, list of events coming in, and list of states coming in. Once I have those, I'm creating maps of them. So in Kotlin, one of the nice things is you can reference constructor arguments on your variable initializations. So I don't have to have an initialization block to do anything there. If I wanted to do something that I couldn't do on an initialization block, I can have an init block. And this runs after any constructors have run. This constructor up here is called the primary constructor. You can define additional constructors if you want, but they all must be defined in terms of the primary. So your additional constructors take their parameters and just pass them to the primary. They might pass some constants to the primary and so on. Okay. If you want to have a bunch of constructors that call a bunch of different constructors in the superclass, you cannot have a primary constructor. You have to just explicitly say constructor with arguments. And it actually is defined as constructor with arguments. Does that make some sense? Okay. Probably not going to affect you too much. Most of the time you want to try to keep it to just a single constructor. And you can have default parameters. The defaults all have to be the last parameters, so you can't have a default with a non-default in between. But this now allows me to call this with either 4 arguments or 5 arguments. And if I only call it with 4 arguments, I get an empty list for that one. Did I count that right? Yeah, okay. So that helps it so you often don't have to have multiple constructors. Okay, so I'm mapping up, basically I'm creating indices on the data that came in here. The map function, anybody here not familiar with the idea of a mapping function? Basically you have a list and it says for each element in that list, change it to be this element here. And you're going to notice this to word in here. The to operator is actually a function that creates a pair object, where this is the first item in the pair, this is the second item in the pair. So this commands map, it name to it, is going to create a list of pairs. When you have a list of pairs and you pass it to the toMap function, it creates a map out of it. Okay, so start state, I'm going to look up from the states that came in the name of the start state that was passed into me. Because at this point, I've indexed all the states, so now I have access to that. I can do that. Reset events, same type of thing. I'm going to look up all the events to find out what that name is for it, for each of the reset names that are passed in. Okay. In my initialization block, this happens after all constructors are run and after all initializers are run. So at this point, I know all my states have been passed in. I've done my indexing on them. I can resolve them at this point now. So I'm going to say, take all my states. What is all states? Oh, I'm sorry, it's a map. So take the map of the all states, get the values, just the set of the values that are in there, and for each one of those, call that resolve method back in the state class. Make some sense? Yes?
Why do you choose to have a string type of state?
The problem is the state might not have been defined yet. So in order to pass a state in, you have to have previously defined it. So I could have defined that state outside and then passed it in as a start state and also passed it in as one of the lists of states that I've got here. But what I wanted to try to do here is set it up so I can say, here's a state machine, here's the name of my start state, here's all my states, and then once the construction has all been done, do the resolution to point them back out. It prevented having an extra variable floating around outside. And similarly, I could have defined all my states up front, kind of like I did in that initial example, where each of them is a separate variable and just use them directly in the transitions. But then that forces you to kind of spread things out in a weird way. When you see the code that actually generates the state machine, this will actually look a little nicer. So sometimes you end up having some extra weirdness being passed in order to make the specification of the data better or simpler. When we get down to the Xtext version of all this, that's when things get really nice because it does all the resolution automatically. I love Xtext. I just wish that the project that I'm working on right now, I originally started when Android was all done inside Eclipse. So I had Xtext as my model generator for me, and it was beautiful. I mean, you had these plugins that ran. Basically, I'd have 2 nested copies of Eclipse running. One that defined my Xtext plugins, and then the nested one where I actually defined my application. And so the nested one, I defined my model, which uses those plugins to generate an IDE. Right up on model, it generates code. All the code compiles together. Beautiful. Then Google screwed me. Google moved Android to Android Studio, which is a pile of crap that is basically an extension of IntelliJ IDEA. And so I tried to get Xtext to run in Android Studio, and it does not run well in Android Studio. So now I have 2 copies of Eclipse open to create my plugin and manage my model. My model generates code into the stuff that's in my IntelliJ project so that I can build it as an Android application. It is gross. The build process is a nightmare right now. And I have Google to thank for that. And I'm trying to change things up now using Kotlin and some internal DSLs so I can put all my stuff, instead of having the external DSLs, use internal DSLs for it and make things easier. But it's a good bit of work. So, but yeah, I love Xtext. It's just, you'll see how nice it is once we get there. Okay, so initialize everything. I have my same little lookup things here so that people on the outside can look up commands, events, and states by name. My reset target, same as before. Command channel hasn't changed. My controller hasn't changed either. Okay. Now let's see how this is used. So test 3. This starts looking a little more like a kind of nested specification of data. Notice these things that are in blue here. You can use named parameters in Kotlin, which is nice because then you can reorder them however you want to. If you use named parameters, they all have to be named. You can't mix and match named and non-named. So in this case, I'm creating a state machine. Here's my reset event names. It's a set of door opened. Here's my commands. It's a list of these commands. Here's my events. It's a list of these events. Here's my states. It's a list of these states. Each state has a list of, I really should have said, this is, actually it's not events. What is that parameter in there for state? Action names. So I could have said action names equals that, and transitions back equals that. So that way, I'd have a little bit more information on that, and I could have done that in each one of these. And we'll see in this one, action names is an empty list. Transitions has those two. Actions are empty for those, and then those transitions are set up in there. Kind of nice, huh? Yes.
You're saying you need to name all of them, but it doesn't look like you need to name the first one. Is that an ordering thing?
That is interesting.
Name them after.
I thought you did have to name. Maybe I'm wrong.
They complained about the first when you just named action names about the next one.
So when I did this,
Yeah, complained about that.
named in position, that's interesting. I didn't even notice that it wasn't complaining about that one.
Actually, this whole giant thing at the top is the same thing. The first one is a string. It's the name of the
Yeah.
state that's not named.
Huh. I wonder if this obviously builds because I ran it there. I wonder if this might have been
What if you
an
take off
early.
the set event names?
Yeah, this one will definitely yell at me. Oh, it's positional until you do one.
Yeah.
Okay, that actually makes sense. So once you've done one, then it assumes everything else has to be. That's kind of gross, and the error message is misleading on that. So if I remove this one, yeah. Wow. Yeah, that's a misleading error message there. So yeah, as soon as you go to named, the rest of it has to be named. Which I don't mind here, but it'd be nice if it was consistent. I mean, right now, obviously, I can't. Well, I could. I think if I reordered any of these, it'll give me grief because of that first one now. No, actually, it allowed that. So once you go to named, you can mix and match from the named ones. So you can be positional up to named. Ugh. That leaves a little bit of a sour taste in my stomach there. I have a what? A who? Oh, linter, yes. Yeah, that's what was bringing this type of error message up here. There's a lot of lint things, and there's a lot of things in the compiler itself. But especially like if you're doing things in Android, then the linter there actually does a lot of Android type checking, saying, hey, you're doing something here that's a really bad idea, like you're accessing a database on a main thread. If it can detect that type of stuff. Yeah, there's a combination of the lint and the compiler here doing its job. Okay, yeah, that's a good thing that's interesting. So yeah, so as soon as you switch to named, it's got to be named for the rest of them. But then the named ones you can put in any order you want. Interesting. So we can see here now that this is looking a lot more like a data specification. And in some ways it gets a little bit more readable, but the thing that I like about this is it helps you mentally group things more. So now you can see here's all my commands together, here's all my states. And by using these strings here, I don't have to worry about the order that they're defined in. I can define the states in any order. And I don't have to have specific variables. But by using the strings, the drawback is I can make typos all over the place in this. And I don't get any build time checking on it. Okay, tests stay the same. Controller is very similar, except it has that defining, go ahead and grab the idle state. I just created a couple little helper functions here that shorten things up. So it says ename, called state machine event name, and so on. So I don't have to have real long names in here for everything.
What's the S wrapping? Oh, sorry, that's your.
That's this one here. So S name just calls state. So in your assignments, please do not do that. I will grade you down because that is not a full name. Okay. So do as I say, not as I do, that type of thing. So let's run example 3. And wow, we get the same results. It's always nice to know we get the same results. Okay, questions on that one? Now there's a few things we can do to make this a little bit cleaner. If I add in a couple helper methods, little helper functions up here at the top. Now what I'm going to do is I'm trying to make things so it reads a little bit more fluently. Because I had a whole bunch of list of this and things like that. So I want to try to get it up so that instead of having to say list of, I'm going to just pass in some varying length argument lists to some functions. So I can say reset event names, pass in these guys comma separated, and just go ahead and create that as a set or create it as a list, create it as a map, whatever. Make sense? So now what I get in here is state machine, idle state, reset event names, commands, events, states. I'm doing everything positionally here. I could still put the named arguments on there, but because I'm actually have these as named functions now, I don't really need that extra name on there. It doesn't buy me much. Make sense? And so that, I think, is even more readable, especially when I added in no actions as a separate function that all he does is send up an empty set there. Boom. Make some sense? Okay. And so if I run this, I'm going to get the same type of thing. There we go. Same results. Okay. Now these do have issues because everything is string-based. And that can get us into some trouble. So now we want to see if we can get out of that situation. I'm going to take a step forward with this, not changing a whole lot here, but what I want to try to do is get myself into more of a internal DSL before I actually deal with the string issue. Let's get things so that we actually are using more of the language features to make this thing look a little cleaner. So the first thing I'm going to do is separate out the actual builder logic from the objects that we're trying to build themselves. Before we had the state machine, everything was getting passed into the constructors, and then we had to track all the raw data inside of our objects and then resolve them. So instead what I'm going to do is have a separate set of builder objects, which are responsible for getting all that raw data and then building things. And let me show you what the test for this one looks like before we actually look at the code. So take a look at what this looks like now. State machine, open curly, start state, command, name code, command, name code, command, name code. Now I didn't have to write it this way. I could have said command, open paren, name and code, and so on. But look at this. This is using a proper DSL inside Kotlin. So this really looks like a data specification. It doesn't look like code quite as much. But this is actually Kotlin code, as is. Getting this to work takes a couple little tricks. But this is kind of similar to what you do in some other languages that support DSLs, like in Groovy, you could do something similar to this. And this kind of looks like Gradle now, right? I mean, Gradle looks, if you've used, how many people here have used Gradle before? A few? Okay. The Android people. Have you guys done Android at all? Okay. Yeah, if you had done Android, you probably would have seen Gradle by now. But Gradle's a really nice build tool, but this actually kind of looks like Gradle code now at this point. Let's take a look at what we had to write to get this to work. So the objects up at the top are a little bit more back to what they were to start with. They're just the thin little objects where we're going to stick data in. So we had our events and our commands. We have our state, which just has a name, actions, and transitions. Our state machine, we're going to pass in all this data, but notice that it's actually the real data now. It's not the list of strings. Command channel controller, all pretty similar. Now we get to the fun part, the idea of the builders. So I'm going to start off with each type of object has a builder object associated with it. The responsibility of the builder object is to gather the data it needs, and then we can create the actual objects. Now I could have put a build method in each one of these. It's responsible for building it and delegating it. But for this example, it was actually simpler just to do it in one spot. So we have our abstract event builder in that. Our transition builder is just going to keep track of the event and target. Action builder is going to keep track of the command. State builder is going to keep track of the name, actions, and transitions. Okay, so they're just keeping track of the data so they can build things. These guys here, transition and action, are some nice little helper methods. I'm going to come back to them in a minute. State machine builder, have all of our data, our raw data that we're keeping track of, which is the individual little builders. And then we have a build method, which is going to set everything up. So now let's start taking a look at the details behind these. This method here. And once you've seen the pattern I'm using for a few of these, it'll start to make some sense. But to start with, this looks kind of gross. So what we're doing here is I'm saying when somebody says create a state machine, and that is this guy right here before the open curly. In Kotlin, if you pass a lambda in to a function, and a lambda happens to be the last thing in that function call, you can put the lambda definition outside of the curly braces. If the lambda is the only thing being passed, you don't need I'm sorry. If you pass the lambda in, you can put it outside the parentheses. Okay. If it's the only thing being passed in, you don't need the parentheses at all. So we'll see here that this call to state machine open curly is actually state machine passing in this lambda as an argument. It's a nice little syntactical sugar type thing. Now I only have one argument coming in, and it's a lambda. We can tell it's a lambda because of the functional type there. No arguments coming in, and the return type is unit. In Kotlin, anytime you just have a function that doesn't return anything, it's a unit. That's what the return type. It's kind of like saying it's a void return type in Java. Okay. Now notice this little bit in front of here, state machine builder dot. This says that that lambda takes a state machine builder as a receiver. So inside the lambda, I can use this as a variable. And if I say this, it's the state machine that called it. So what I'm going to do inside here is create an instance of a state machine. I'm using this let so that I have it holding on to it. And then pass it to that init. So that this new instance of the state machine builder gets passed in as this to that block. So inside here, when I say start state equals idle state, I'm actually accessing the start state property of that state machine builder. I could have explicitly said this dot in front of that if I wanted to. But by not putting the this dot on that, it makes it a little bit more data-like. Make sense? So I do that, and then at the very end here, I'm going to call it.build on that state machine builder. So I'm going to first of all do all my initialization. So it's going to take that whole block and run all that code. That defines all my states and everything. And then I'm going to call build. And then the build actually is going to set things up. So I'm going to create a couple indexing things here. So I'm going to index my data, my commands, my events, and states. Kind of like I did before. It was indexing, but it was inside the state machine before. And then for each of those states, I'm going to take the transitions and set them up. I'm going to find the state, set up my transitions for that state. I also have inside my state machine builder these functions, event, command, state, and reset event, which look very similar to that state machine before. So I'm passing in a lambda that takes the event builder as its receiver. and I'm going to call a common setup method on these. All the setup method does is take in the thing that I'm trying to set up, take in a list that I want to add it to so I can track it, and take in that lambda. Initialize him, add him to the list. That's all I'm going to do there. So this is going to create my event builder and add it to the events list, run as init. Create my command builder, add him to the commands list, run my init. Create my state builder, add him to the states list, run my init, and so on. Make some sense? And then my reset event, I'm just taking a name and adding them to my reset events list. In my state builder, once I'm inside a state, I can add transitions, I can add actions. Same pattern going on here. I take in a lambda that has a transition builder as a receiver. And in this case, I'm calling it a little bit differently. I could have used a let here like I did before. I'm not sure why I chose to use an apply here, but it just struck me at the moment that I did this to use an apply. What this says is create that transition builder. Once I've created him, call apply, which does two things. Passes him in as this to the block, and then automatically returns this at the end of the block. So this is apply is a great way to initialize things. So I create him, do some stuff, and then return him. The stuff I'm going to do is the init just like before and add him to the transitions list. This one, init, add him to the actions list. So what I really could have done is I could have taken this same setup method and moved it out and reused it everywhere. I think what happened when I was writing this is I wrote this state builder, did all this, got into the state machine builder, something distracted me. I came back, started writing the code for all these. I'm like, I can just use a common function, and didn't think about going back and changing this to use a common function. But it's doing the exact same type of thing. So this little idiom here of passing this guy in as an initializer is what makes DSLs possible in Kotlin. And now I have this kind of a structure to define things, which looks a lot more like a data definition. It almost looks like JSON. Okay, questions on that? Go ahead.
Main advantage to doing it this way over parsing JSON is you're just trading off the need to parse the JSON over the complications of dealing with lambdas and other objects.
Okay, so the question was, what's the advantage of doing it this way versus just reading in some JSON, which could do the same type of thing? There's a couple things. One is speed. So if we were doing this at runtime, the speed's going to be a little bit faster doing it this way. If you had a very large JSON file, this might be a good bit faster. The disadvantage, the trade-off, of course, is you can't be dynamic at runtime. You're stuck with this just at build time. The big advantage to this guy is that you're getting build time checking. So if you made a typo on this, other than the strings, and we're going to come back to that later, but other than the strings, you're getting build time checking here. So the structure, you're sure it's going to be syntactically correct. With JSON, you can miss a curly brace, a bracket, whatever. But the advantage JSON has is at runtime, you can have a different data. So every hour, if you wanted, you could ship a different data down. Every time you run, you could ship a different data. The user could select something saying, load this versus load this. So you're trading off some dynamic capability for build time checking and performance. This is an internal DSL. JSON would be considered an external DSL, yes. So, and a lot of times people don't think about JSON as being an external DSL, but it really is. It's a language that's specifically designed as a kind of very generic data carrier, but it is an external DSL. So it's really, there's that constant trade-off and pushing on that. And once you're used to the idioms, I mean, you're probably, obviously you're not used to Kotlin yet. And have you used lambdas much in other languages? Yeah. So it's like lambdas are one of those ones that if you haven't used it much, the concept can be a real kick in the butt to start with. And so getting used to them, in this case, this is one of those ones where this type of pattern is the same pattern over and over and over again. Once you've done it a few times, it becomes a lot easier to understand. They have some great examples on doing it for HTML. So you can basically define an HTML document using something like this. Not quite sure why you'd want to, but it's, that's again, the internal versus external DSLs. If you had a web service that returned some formatted HTML, that might be a decent way to do it, because inside there, it's still Kotlin code. So you can actually put code inside those blocks and, do things conditionally even if you wanted to. But there's a trade-offs there of, compile time checking and performance versus dynamic capability. Okay, so other questions on this one? So, go ahead.
You're passing in a lambda,
Mm-hmm.
but you're actually the lambda's referencing the constructor of
Not the constructor, the actual instance that was created. So in this case, these ones are a little bit more clear, I think. In this one here, I create the instance of the object, and that one I'm calling on. So
What's
it's
that last one on the end there under emit? Oh, that's to call the
under which one?
on the
Oh, over here?
line 103. What is that line? What is that part?
This part here?
Is that just what you're returning?
So actually, if I wanted to return something, I would say colon, return value, like that. This is just an argument coming in. So this argument, we're calling the argument init, and his type is this guy over here. So the first thing to look on this is ignore the t dot. This paren arrow unit. Anytime you see parens with something or nothing inside of it, arrow some value, that's a functional type definition. So you can pass in any function that doesn't take anything and doesn't actually return anything for that guy. By putting the t dot in front of it, it's saying that I can call it as an extension method. So I'm going to pretend that this is a function on that type, whatever the type is. And so by saying item.init, item is of type t. T is valid as a receiver on that. So I can pretend that item actually has an init function now. And then he calls that. If I wanted to, I could have types inside there. And then put in some string into there. Whatever. And then it would pass that string in as an argument to the constructor, or to that initializer. I'll come over here and delete him. By the way, while I'm thinking about it, primitive types, there are no primitive types in Kotlin. Under the covers, it'll use things as primitives if it can, but things are treated like objects in Kotlin. So the type for integers is int with an uppercase I, double, uppercase D, things like that. Okay, there are no lowercase types on those guys. Okay, other questions before we move on here? So, go ahead. It's fun, isn't it? Actually not. It's actually, in Kotlin you have things called extension functions. So you can define a function, like if I came out here, I can say fun state machine builder dot foo. And now it treats it as though state machine builder has a foo function within the scope of where this function is defined. So inside this package.
So you're actually tacking on an emit function there to each thing past it.
And actually, it's actually an unnamed function, unfortunately. But I'm calling it init as a parameter coming in there.
So then where is the emit that you're passing in as the argument?
Okay. So let's come back to this guy. Whoops. Let's go back to test. So let's look at the command here for a minute. So command is a function that takes in a lambda, and this is the lambda right here. So I'm defining this guy here. This lambda here doesn't take any arguments, and he doesn't have return value. He is getting passed in the command builder as his this parameter, as his receiver.
So that's an inferred. That's an inferred argument.
Exactly. Well, not really an argument. It's receiver because it's coming in as this. For something like the let down here, he actually passes this guy in as an argument. So this lambda here has a single argument that by default is it, but I could have called it state machine builder like that and had him defined like that. But then I'd have to, of course, change these its to SMB. Yeah, lambdas take a little while to grok in Kotlin. They get easier over time. This is the extension function versions of these are the trickiest ones to get. Extension functions in Kotlin, the one thing you have to be really careful about, they can be really neat, and there's some places I like using them, like if I'm defining a template. In Kotlin, when you're defining strings, you can say val x equals $y colon $z, something like that. And let's say I had val y equals 42, val z equals int, I don't know, something like that. That's completely backwards, but whatever. Let's say that made some sense. What this is doing is this defines a string and replaces the values. If you wanted to do something more with y, you could put curly braces around it and say like y dot to float maybe. And then it'll do the conversion inside that as expression. Extension functions are really nice if you want to do something much more complex at this point. So if you had a large AST and you wanted to generate some code, I could define a template that has the stuff to define there in quotes like that with $ replacements. But if I wanted to say at this point I'm generating all my functions, I might want to create an extension function on a list that I can just pass in that list of functions and have it produce another template there. So it actually would iterate over that template multiple times. Boy, that just went in the weeds, did it? I'll show you an example at some point later on when we talk more about code generation, because I've done that a few times, and it's actually, I might actually have, in this new example I was playing around with. Let me see. Did I put it under my get stuff here? There. I think it's in here. I was playing around with a new idea. No, I don't have it in this one. I can't remember where I had that one. I'll have to see if I can find it. But I had an example of generating some specialized enumerations using a Kotlin builder for it. And it was a nested set of templates. Yes?
What's an AST?
Oh, abstract syntax tree. Sorry. Yeah, coming back to that. There's a term. Yeah, feel free. I mean, if I'm using acronyms that, I did define that one though. But if I use something and you can't remember what it meant, yeah, anytime, pop it back up. Yeah, but if you had an abstract syntax tree of stuff, like in the example that I was working on, it was a specialized type of enumeration that's nested. So in what I used to have is this set of enumerations. You choose a value from one enumeration, and then it picks a different enumeration to pick a secondary value from. Sometimes you might have two spinners next to each other. So instead, I created this new type of enumeration that allows you to have top-level guys and then nested nodes, and they could have nested nodes. So you could do things like, what type of agent are you dealing with? Chemical or biological or whatever else. And then underneath chemical, is it a blistering agent? Is it a choking agent? Whatever. And then underneath there are the different types. It was really nice to be able to do that. And I had these nested, I almost said things, these nested template strings to do that. And extension functions made it real nice. I'm going to see if I can find that example and bring it in for next time, because it's a neat example to look at. Okay. So that gives us this as an internal DSL in Kotlin, which I think is really pretty readable. And you can access your variables appropriately. There's a couple issues in here with the way I've defined it right now, because these guys can actually reference variables outside, like inside here. I could actually say start state equals something. He still has visibility to him, which I don't want to do. They have an annotation you can add on your DSL stuff to say restrict it to just me and nobody else. I can't remember what that is off the top of my head, but I'm going to look that up and use it when we talk about these in more detail another time. We will be coming back to these. This is just kind of the grand vision situation here. Wow, time is actually flying now. It's like I get in this kind of halfway point. I'm like, wow, I thought I had more time than that. So let's see let me try running him first just to make sure that he still runs. So this is test 5. Because the more interesting stuff comes next. Boom, he ran. Yay. Yes?
Will there be a walkthrough on like how to install Kotlin?
Oh yeah. I will be going through all that stuff. There's no assignment starting this week. But yeah, what I'm going to do is as I'm getting into the individual concepts a little more deeply, we'll walk through exactly how you set everything up. Okay. And if there's anything you see me do in the environment that it's like, how did you do that? Feel free. Now, number 4 gets a little bit more interesting. What I'm doing here is bringing Antler into the mix. Antler is a parser generator. And what we're going to do is define a grammar to define what we want our DSL to look like. And the DSL that I'm creating here is this guy right here. So this little one here, this is an external file that's, I'm calling it .gothic as its extension on here. And this guy defines a state machine called Gothic. His start state is called idle. Command is unlack panel, code, blah, blah, blah. Same type of data, just a different format. And this is a string, this is the language that I just made up. You'll notice things like on door close, switch to active. So here's the event, here's the state that I want to go to. So fairly readable, fairly concise. We're not relying on any specific languages, constructs, or idioms or anything like that. To create this, I created a grammar. So the grammar looks like this, and this is an Antler grammar, calling it Gothic Security. And I have a state machine, which is going to have that word state machine, an ID, and then open curly brace and a bunch of stuff. Start ID, 0 or more commands, 0 or more events, 0 or more states, 0 or more resets. Okay. A command is the word command, then the ID, then code, and then ID. So these are literals, command and code there. State, and I'm going to go over how to do this in a lot of detail later. Not today, but another class. State, ID, and then have 0 more transitions and 0 more actions. Okay, make some sense? All these yellow ones here are parser rules. These are, if you think about a parser generator, a recognizer, think about how we read a book. When you look at a book, what do you see in a book? Go down farther. Letters. You see letters, right? What do you do with those letters? You group them into words. At that point, you see the words. What do you do with the words? Group them into sentences. So we do the same kind of thing with parser generators. Down here, we have what are called lexer rules, ID and whitespace. And these literals here are lexer rules themselves as well. That says when I see a sequence of characters coming in, how do I want to group them together into words? This guy is saying if I see any white space, skip them. Just throw them away. But use them as dividing marks for other types of tokens. If I see lowercase or uppercase letter followed by lowercase, uppercase letter, possibly with numbers, any number of them, I'm going to treat that as an ID. So that's how I'm grouping these things together. And this says if I see ACTION, consider that the word action. Once I have those words, I want to group them together so I can gather meaning from them. That's what these parser rules do. So this says if I see the word command followed by an ID, followed by the word code, followed by another ID, I'm going to understand that as a command. Make sense? Now what Antler does, this is version 4 of Antler, is he generates a parse tree, which is kind of like an abstract syntax tree. The difference is a parse tree is explicitly showing these rules as nodes. And then underneath there, the terminals that you saw, in this case IDs, and the subrules that you saw inside there. So it's basically making an explicit tree out of the parsing structure. Now note that the parsing structure is often different than an abstract syntax tree. Abstract syntax tree is typically how you want to organize your data before you take it to further passes. A parse tree is just a direct implementation of what you see as the rules here in your language. Does that make some sense? They can be used for the same thing, and in this particular case, I'm using them for the same thing because I get a parse tree and I work through it to do something with that. So if I take a look at my code on here, you'll see I was doing some debugging. This is my new model. Looks very similar to the first model that we had. It's just data. But I need some way to create those objects. Now in this particular example, I just put it directly in my test, but I could have put this in a separate class and really should have. This guy here, Gothic Security Listener, is generated by Antler. Let me show you what gets generated. So in my build, I have generated source, Antler, main, bloomp. He generated all this gunk for me. We have a lexer, we have a parser, we have a listener. The listener is a parser listener, and he receives events when we see certain nodes in the tree. So when we enter a node, when we exit a node. So what I'm going to do is I create an implementation of this. Object : is the way that you create an anonymous inner class in Kotlin. So I'm just saying I'm going to create an instance of this guy, and here are the guts. It's just a little bit more explicit than anonymous inner classes in Java, which were always fun to read. But if you want an anonymous inner class, just object : And so then I'm defining all these methods: enter state machine, exit state machine. So what to do when I first see that node being created? So I've first gone into that state machine rule. I'm just going to create a state machine object and hold on to them. And there's a variable out here for that. Exit state machine, that's when I'm going to start doing all my resolution of things. So I'm going to go through here and fix up my transitions. I'm going to assign him a name. So when I exit, by the time I've exited the rule, I've already had all those IDs filled in. I've had all the subrules called. So I know that I can look at this context, and his ID, the first ID, 0, is the name of the guy. The second ID, number 1, is the initial start state. If we look back at our rule here, first ID is the name, second one is the start state. So I'm just pulling that data out as I'm walking the tree. And the stuff that happens in here is very similar to what happened in those builders. So I wrote this code here to set up the data. Unfortunately, it's a little spread out because you have all these enter and exit methods. But it's doing essentially the same thing. That creates my state machine. And then after, I end up doing my calls on it, just like before. Now up here, the initialization up here says I'm going to create an input stream from that file. So that's what I'm going to read from. Create an instance of my lexer passing that input stream in. So the lexer is going to pull stuff out of the input stream to say, what are the characters I'm seeing? Give me characters, give me characters. He's going to take those characters, assemble them into words, otherwise known as tokens in parsing parlance, and push them into a common token stream. The token stream goes to the parser who's saying, give me a word, give me a word, give me a word, give me a word. Let me figure out the meaning of it. And I figure out the meaning by calling a function on the parser. State machine, state machine. This is a recursive descent parser, so it's actually going to walk through the data and say, do I see the word state machine? Pass an ID in. What do I see next? What do I see next? At this point, do I see the word command? If not, do I see the word event? If not, do I see the word state? And so on. Yes?
And then order matters, right?
The order here matters. Yeah, the way this is defined. There are some constructs in, did Antler have that, or is it Xtext? Might be Xtext I'm thinking of. There is a way to say for like keywords like protected and private and all that, that I'm only going to see one of them in any order. Or, possibly one of each in any order type things. If you don't have that in the parser generator language itself, you have to say accept them all and then have a validator pass that actually runs through and says I don't see public twice. But if I just said, I could say something like public or private star, and that would let me have public or private in any sequence, but I could also have multiple publics and multiple privates, so you'd need to have that extra check. Okay, make some sense? Let's run this guy. Now this one is using an external DSL, so I'm reading this thing in at runtime, so there's an extra cost at runtime for this to actually happen. So I'm going to run test 6. Boom, everything ran fine. Now this is the one where the generate grammar source was actually triggered, and it ran in an earlier build. If you notice this guy here, I had it print out, let's see, where is he? I had it call println on the toString tree for the parser. So what that did is that just prints a string representation of the tree itself. So you basically are just seeing the list of tokens and some groupings around them. So you can see how this stuff is actually assembled Okay, make some sense? So this is one type of an external DSL, and I'm using this to read the data at runtime. Now the one that I really like out of all this, and again, this depends on if you don't have to have dynamic, be able to change things at runtime, is using code generation. So if we take a look at this next example, I'm starting with xtext. And xtext is defined inside Eclipse, which I did not open yet. Let me open him up. And what I'm doing here, if you look in this project, you'll see that it references Eclipse down here. What I've done is in my build.gradle, I added in a source set, added to my Java source set, the location of this Eclipse directory where it generated stuff. Generally, this is a bad idea to have a hard-coded path like that. Usually when I do cross projects like this, I have the Eclipse stuff and the non-Eclipse stuff underneath the same parent directory, so they can use a relative directory path. But when I was creating this example, I didn't think ahead on that much and just was trying to do this fast. At this point, it got to be about 3 in the morning. And so I wanted to get it done. So I just put in the hard-coded path. Try to avoid hard-coded paths in real life. But this is basically saying take what was generated and add it to my source here. So we'll see in here that underneath, I think it was in here, yeah. Here's test 7. This code was generated. And if you look at this, it looks really similar to the very first kind of hardwired example we saw. But this is all generated. And let's see what it's generated off of. So in Eclipse, down here, this guy, I created an xtext project, and there's 2 files that I had to edit. This one called xtext, and this one called generator. Let's take a look at the xtext one first. And he's microscopic. Can I change the font inside here? Does control scroll work in Eclipse? No, not here. It might be something you can enable to do that. Let's see, colors and fonts. Where was the text font? Ah, I had it. And let's go to one more, 28. There we go, much better. Okay, so this is the grammar that I define in xtext. It's fairly similar, and I'm actually, the language that you can specify here is exactly the same as the language I used for Antler, but the specification is a little bit different. He actually uses Antler under the covers to do the parsing. So see, I say state machine, but you notice how I added in name equals in front of that ID. What xtext does for you is by specifying the grammar, he automatically creates readers for it. He creates model objects for it. So there's actually a state machine model object that has a name property, commands, events, states, reset events, and tests, and start state. And he fills all the data in for you automatically. So as you edit the thing, he's constantly updating this thing. He also deals with references to other objects. So start state is a reference to another object. So I don't have to do that resolution crap anymore. It's automatically taken care of. Yes?
Why is name orange and like commands, events, the other properties?
That's a good question. I don't know. I didn't write their parser or their syntax highlighter here, so you'd think it should be. Oh no, you know what it is? Name is special. That's the thing. When you say reference state here, by default it uses a name property of him, if a name property exists. Otherwise, you can pass in like state. Does he have something else? I could say code. You can do something like that, or it's the other way around. Yeah, otherwise you can do something like this. He's not liking that. Well, assuming state had a code, yeah, he doesn't have a code, but if he had a code on it, you can explicitly say which property to use, so when somebody types in the state, it would be that one. So he'll take care of all the resolution for me automatically. By defining this, it defines an editor for me with syntax highlighting, with content assist, with hooks for doing all sorts of other things like quick fixes and stuff. And the grammar is really similar to what I had before. But I didn't have to define an ID or white space because that's taken care of by saying use my common terminals. Okay, so I define this, and then I build him. So I'm going to take this MWE file, which is just their builder language, and say run as workflow. It's going to generate a buttload of stuff for me. Metric buttload, not imperial. Okay, and that's done. Down here underneath source gen, this is where it's actually defining all these objects for me. Under the covers, he uses a framework called EMF, which is an Eclipse thing. But it's just some common libraries. You can actually use it in a non-Eclipse project. And then I write my code generator. And here's my code generator. The Xtext generated the base generator for me, and then I filled in the details. So he had this do generate method with like a little simple example in there. So what I'm going to do here is when do generate gets called, that's the root one. I'm going to take a look at the resource that's passed in. In Eclipse, it represents all its files as resources, and the resources can have contents inside them and so on. That's the EMF framework. So I'm going to say resource, get all my contents, filter it so I'm just looking at state machines, and get the first element out of there. So it's a streaming API thing, kind of like Kotlin has. And then I'm going to say take in my file system access, generate the file test.kt, using the results of machine generate test as its body. So here's generate test. I'm defining him, passing in state machine as the argument. If you want to, you can pass it in as a receiver, and it just, if it's the same as the first argument type, it just uses as the first argument for you. So it's an extension function, kind of like in Kotlin, except it's not as explicit. This guy, I'm going to use a template. That's this triple single quote here, ending at this triple single quote. And then here's the code that I'm going to generate. So I have warning this has been generated. I'm explicitly hard coding the package name. Normally when I'm doing a DSL, I don't do that. I have the DSL itself have the package name inside of it. But for this example, I'm like hard code, passing in the same stuff that I started from my initial example. And then here's where all the fun stuff happens. So they use this little, what is it, Guillemot or something like that? I can't remember what they call it. I call them creepy European quotes. So they use the creepy European quotes around the control structures inside this templating language. In Eclipse, you can do it by doing Control Shift and then less than or greater than, and it puts those in. I got really used to typing in Control Shift because I've used this one a lot, so it actually gets pretty easy. So for each of the events, I'm going to say val event name equals event name in quotes, event code in quotes. Nice simple little templating language. If you have a good templating language, code generation is easy. Harder template languages, it makes it a little more difficult. But this one, it's actually fairly readable. I mean, you can really see what code is going to be generated out of this. And in some cases, I put a blank line in between these guys. But then here's each of the tests. Now, in this one, I extended the DSL a little bit to have the tests specified. And if we take a look at the language here, a test references events. So I just say test name with the events that I want to fire off to test it. So all this generates my IDE for me. I can then run a nested copy of Eclipse by saying run as Eclipse application. It has its own workspace. It's using this as plugins, basically contributing to the Eclipse environment. And now inside here, I created my config.gothic file. And let me make him a little bit bigger. I can't believe I had to look for this. I used to know this like blind where these things were in Eclipse, but
So it doesn't inherit the preferences of the
it's a completely independent workspace. That's intentional.
sort of pain in the ass.
Well, you can copy, you can export and import if you want to, but they do keep them separate so that when you're testing, it's not affecting your base settings. So here's my state machine. Notice it has syntax highlighting on this. Has all my states and things. Has all my tests. But where it gets really cool is that down here, when I'm choosing an action, I can hit Control Space and it gives me all my valid actions. And it automatically links him. He's no longer a string. I don't have that issue with the strings. And this allows my editor to keep everything consistent. This is the advantage of something like a language workbench. When you have an IDE defined to do this, you can use your types and reference your types and have it manage the data for you. And if you use this at build time, like I'm doing it to generate code, or at runtime to read this file, it'll assemble those same objects for you. And the objects, have all the linking resolved for you. So nice and simple. And if I was, creating a new feature in here, I can just hit Control Space. What can I do next? So I can have action on or the curly brace to close it. So if I want to define a new on, I can say on, and then pick light on, switch to idle, for example. Things like that. Why didn't it give me the other? That's interesting. That just gave me idle as an option there. That is, oh, you know what it is? It's because I hadn't finished this, so the rest of the code is in error, so no other states are defined. That's interesting. So I had to at least put something in there so that syntactically it could say the other states are okay, and then I could come back and fix this. That's interesting. Now I probably could set up some error recovery settings on that. Error recovery in compilers is a real fun task. One of the things that's neat about it is I used to use a compiler a long time ago, AppleSoft Pascal, on the Apple II Plus with 48K of RAM. I did say K. And on this compiler, it would run the compile and stop on the first error. I was doing a graphics project in college using this. It took 25 minutes to compile my code. And when you compile your code and get missing semicolon on line 7, after 25 minutes, you get really pissed off. It's worse than the speed of our Mantis build right now. And so this thing it drove me completely nuts. So you did a lot of desk checking. Syntax highlighting helped that so much. I mean, that's I think one of the best advances in computer science has been syntax highlighting editors, and doing analysis while you're editing to tell you. I mean, that's been huge on saving time. So when I save this, one of the things I love about Eclipse so much is that as you save things, it's automatically building things. So as soon as I save that, boom, it generates that file. Now, why did it go to? Oh, this is Kotlin. It's a different language, so it had a different font size. So boom, it generates this guy. If I come over here, and let's say that I added a new state. Come over here, I now see that foo is a state in there. So edit, build. Now if I go back over to here, you'll see that he's seeing that in his editor because he's linking him as source. If I run this guy, same result. Text is a little different because I had the names. I had to put a valid ID name in there because I was using the default ID support. But boom, there we go. So that's an example of code generation. I could have also, why was I double clicking on that? I don't know. I could also have used this at runtime and read that file in at runtime. If I edit it in that editor, it's going to help me make sure the syntax is correct. So that's still got an advantage, even though at runtime I'm reading it dynamically. So that editor buys us a whole lot of build time support to try to make sure it's a valid file before I even send it to the field. So in a case like that where you still want that dynamic capability, having an IDE automatically fill that out for you and basically validate it is a huge leg up there. And Xtext goes even farther than that. There's, come over to, oh, I don't have that set up right. But one of the projects I have, you see these other projects over here are defining a model for one of my projects. And let's see if I can just open up one of these, show you what the model looks like. He'd be a good one. So this guy here, you'll notice that he's referencing Java classes. So you can also, with Xtext, reference stuff that's brought in from a Java virtual machine and have, where might be a good example? So in this case, I'm calling a static method on a Java class to initialize it. So this one here, for example, is when I was defining those models. I can say I have a class, and there's information in here. This is a string, this is a calendar, this is a map. In this case, you'll see that I have this key singular and value singular. The name of the thing is data, but I talk about each individual key and sets of keys, so that I can have different methods saying get keys versus get key for a specific item. Here's my where's an example? Here's what this enumeration tree looks like as far as specifying it. So it's very data driven. This I set up as any pound anything to pound is just a random string. So I was using that as kind of an escape, but it's a single token for just a random string. And then this lets us have a zoning district type. Here's the types. Vehicle is a zoning district type. It sounds weird, but it made sense for this project. And then here's the vehicle types. This is the one where I was mentioning biological agents and things with nerve agents, blister agents, and so on like this. None of this is classified, by the way. That would be bad, wouldn't it? But DSLs like that, they can really help you as far as generating the code and or validating things for you. So I mean, I absolutely love Xtext because of, the editor it generates, just the default editor. All you have to do is create that that grammar, and boom, you get an editor, and you get a data model, and you get the thing that read it to and from. I mean, it's fantastic that way. But you can add so many more features to it, like you can add extra validation to it, to walk through and say, hey, let me make sure they didn't start their name with an uppercase or something like that. So neat stuff. Yes? Where's the what? Oh, here? Yeah, so this is the nested eclipse. If I go back to the outer eclipse, that's this generator that I was showing you before. So this guy here, he's automatically called from the rest of the plugin. So in the plugin here, they have which one was it? There's this module class. They use a injection framework. They're using Guava here, and so these guys here tell how to configure each type of thing. Let me see, generator. That's the wrong word to look for, isn't it? So let's see. Fine, DSL generator. There he is. The last thing in there, figures. I would have been going forever there. So what this is telling it, it's telling it to, whenever it needs a generator, to use that as the generator for it. And then that says, read in my data, get the generator, pass it to the generator, and tell the generator to do its job. And boom. So they've got it very broken up so that you don't have to change too many things. So I can do things like, where is this? I can set up name providers so that I can make sure that names are unique, perhaps. Anytime it sees a name, it'll pop it in and then say, here's my set of names that are valid. That actually ends up being used for the content assist. And you can pass in scope providers to say, in this specific location, limit the names that are allowed to this set of names. And so, in this particular one that I did, oops, let me go out to, in this implementation here, when I first started writing this, I was trying to put the tests outside of the state machine scope here. But then the event names weren't available because those are scoped inside state machine. So the default scoping was stopping me there. Now I could have taken the time to write a scope provider and had my tests on the outside and had the scope provider say, when I'm in a test, look for the state machine and get all his events and make those all available. I just didn't want to spend the time on it, so I just moved it in. So it gives you a nice little scoping support on that.
So if you wanted to change your generated code to have, instead of just printing out your test cases, you actually want to put a certs in it or something?
Mm-hmm. So if I want to make a JUnit, yeah.
Yeah. Would you have to rebuild the internal project also, or only that
So the first thing I'd have to do is, where did it,
You just close it.
how did I get, oh crap, I hate it when that happens. Let's see, window, perspective, reset perspective. And I should save this after I get it how I want to. At least I remembered how to do that. So first of all, what you'd do is you'd close out this nested guy. Just set him aside because I'm going to be modifying the plugins that contribute to that nested Eclipse. And then inside here, I would change my generator. So I'd come in here and make some changes, whatever my changes are. Save him. And I don't need to regenerate. The only time I need to run this MWE is if I change the grammar itself. So change whatever I want in this, and then I can run the nested guy again. I usually like to run the nested one in debug mode, because most of the time if I change my template in here, it'll actually get reflected automatically in the debugger. Once in a while you'll change something that affects a method name, and then it has to abort. I mean, it can't modify the running VM. But in here now, if I just go in, just tweak it and save it, I'll get the change. So if I look at source gen test here, I see the AAA on there. Now if I come back over here, I'm still running the nested one. Just tweak this guy. That one should be okay. Come out here, touch this guy, and when I save it, he's back. So I can actually edit it. This is something I do a lot. Usually why I run in debug mode is because if I tweak my code generator, I don't have to constantly restart that nested Eclipse. But there are times, like if you add new methods to the generator, it can't do hotspot replacement. But yeah, I mean, I could change that to be a JUnit test if I wanted to, which would make more sense. And it was one of those things I was thinking up front when I was doing the tests. I was thinking, do I want to use JUnit? Do I not? Another dependency, and then I have to deal with how do I do JUnit in Kotlin? I'm not quite sure yet. So, I mean, it's similar to Java, but I just haven't done it before. So, okay. Any questions?
So if you had any luck getting non-programmer users to be able to edit in this kind of an approach, or is this
I actually have. There was so the question was if I had any luck getting non-programmers to use stuff like this. There was a project that I did for TSA. And I'm talking about the TSA people who work at the TSA headquarters, not the people at the airports. People at the airports, no. I mean, I've met a few of them. Some of them have been decent, but like one guy, I used to have a pocket knife on my keychain all the time. I've had to mail that thing back to me from the airport like 12 times so far because I keep forgetting to take it off my keychain. Well, the last time that I forgot to take off my keychain, I went there. They, put my keychain through and they said, hey, can we, you have I'm like, oh, I forgot again, didn't I? And they're like, yeah. And I was like, I've done this like 8 times so far. And I said, I know the drill. Let's go over there. So the TSA agent walks me over to where the little container is that you have an envelope, you put it in, fill out your credit card information for $12. I mean, I paid for that keychain like 6 times is what it's worth. And then put it in there and they mail it back to you and it's worked great. So we go around the corner. He looks around and then says, hold out your hand. And I'm like, what? He's like, hold out your hand. So I hold my hand out. He puts the knife in my hand, folds my hand over the top of it, and he says, put it in your case. What I can't see, I can't take. And I'm like stunned. I'm like, yeah, this is security theater at its finest. It's just nuts. But anyway, the TSA headquarters guys, this one guy had a task of, they have this system called FlightAware. And no, it's Secure Flight. That's the name of it. And Secure Flight does a check of people on the no-fly list versus the people who are registered to fly, and tries to match them up and say, hey, here's a list of people that you got to double check. And there are problems with this list. The list is about 1,500 people long per day, and somebody has to eyeball all these. So he wanted to have a way to narrow that down. And he had some ideas for some rules, like, when I see certain matches here, these are legit, yeah, this person can't fly, versus this is just a bogus entry. One of the types of bogus entries was, here's this person with passport number 42, passport number 42, they're a hit, and it would report it. Passport 42 in the US versus passport 42 in Egypt. So they had that happen a good bit of times. So he wanted a way to do that. So I talked with him, and he had a little bit of technical knowledge. Not a whole lot. He wasn't a programmer. But I was able to talk with him at a level where he had the idea in his head of, I want a rule with a condition. And the types of words he was using, there was a certain amount of, okay, I think he can handle this. So I said, here's what I want to do. I want to write a little language for you that defines some rules. You can edit this file to specify your rules. I'll write a little engine that'll just check against these things. And they were real dirt simple rules. It was basically, when name 1 equals name 2, and country 1 equals country 2, skip or flag or something like that. So they're real simple rules. And when I was talking with him, he got it. I mean, he saw what I was trying to do. He understood it. He liked the idea. So I go back to work and I start implementing this thing. And my program manager's like, no, wait, you can't implement yet. You need a design document. And I'm thinking this is going to be 3 hours of work for me to do this thing, because I'm going to write a little DSL using Xtext. I'm going to do this and the other thing. So I'm like, okay, so I whip out this design document in about an hour. Send it off to him, go back to coding it. I code the thing in 3 hours. I'm ready to send it out. We want to do a little testing before, but I'm basically ready with it. Program manager comes back and says, this isn't good. I don't understand it. I'm like, well, you're not the target audience. He's like, well, I need to understand it. And this program manager had no clue about anything. He barely knew what a computer was. And so I rewrite stuff. I end up rewriting back and forth with him for 3 months for what ended up being a 2-page design document. And it should have only been a half-page design document. I mean, finally I convinced him after 3 months. It's like, and he still didn't understand it. And I said, and I really wanted to tell him, nobody's going to read this damn thing. And finally we got it out to the person at TSA. The guy loved it. He worked with it perfectly and beautifully. I mean, it captured exactly what he was trying to do. It wasn't too programmy. I mean, it was, very, very, very simple little programming language for him. But the rule definitions worked for him. And it's like, a lot of the times, you're not going to be able to get that to happen. I mean, there are some languages where if a group already has a really well-defined way of writing things, like mathematicians. I mean, math is very standardized. You can use that as a DSL. There are some, chemists. They have certain notations that they use that you can put into a DSL. If you're going to start, drop casing things, doing superscripts and subscripts, then you're going to have a customized editor for that. But they have certain notations they write things in, so you could use that. If they already have a well-defined language, then it's actually pretty easy. I mean, it's more work on your end to tailor to what they're used to. Then when you have cases where, you have you need data being passed to you somehow, you got to try to decide, well, what's going to be easiest for them? If they're really comfortable with XML, XML might be the way to go. Most people aren't, and there's, a lot of things that can go wrong with that. You could write a tabular type editor or a tree type editor where they can just add nodes in and then it generates XML behind the scenes, so they can enter things more, in a more comfortable manner for them. It really depends on your audience. You have to sum them up, and if you get a good feel for them, like this one with this guy. He's the best sponsor I've ever worked for. I mean, the communication between him, he knew how to describe what he wanted, and he understood just enough tech that he was able to get what I was proposing. And we were able to communicate just beautifully. When you get a situation like that, it's easy. I mean, you find the right level, you find the right language. I mean, somebody who is more technical than that, I could have come up with something a little bit more fancy. But at the same time, I wanted to anticipate the next person down the line. So I wanted to keep it fairly simple. But yeah, I mean, it can work. I use it internally more than with customers, though. So most of the time, what I'm using it for is, different type of model generation, form generation, ways of making my life easier. And, making my life not just easier, but much more consistent. Because, when I'm generating, 60,000 lines of code, I don't want to, have a mistake in 10,000 places, or have it at least be the same mistake in 10,000 places, so I can find it and then fix it later. But yeah, I mean, it's something that depends on your customer. It really comes down to that, and their domain. if they have an existing language that already works. Okay, any other questions? But yeah, this one I would not necessarily. This is one of those ones that you might be okay with an installer writing up, because the goal of this one for him in the book was that the programmers write all the code to deal with things, and then when somebody goes to install, they can write a little configuration for it really quickly. This one might be simple enough to do that, but they would definitely need training on it. So, okay, any other questions?
That code generation part where you're just writing plain text instead of a triple quote.
Mm-hmm.
Is there a way to actually have syntax checking while you're writing?
While writing this, yeah, there's actually inside here, like in the guillemots. So anything that's outside of the guillemots is just raw text. I have no idea if I'm pronouncing that right. It's something like, it's guillemots, something. But things inside here, you have content assist for. And so it's like, it's full assist on, the little language that I'm using here is called extend, with a lowercase x, uppercase t, and then END. This is a language that the people who created Xtext came up with. And inside here, state machine, I can hit control space and it tells me all the stuff that's valid on state machine. But up in here, no, it's not. There's a code generator I tried writing a while back. I wrote a set of tools. I don't have an internet connection, so I can't show you. But I wrote an annotation processor that generated Java beans. So you can, in the annotation at the top, you could say, here's my properties, and it would generate all the getters and setters for you. With Kotlin, I don't need to do that now. I just say val or var. But what that was doing, I wrote my own code generator that you create Java code and then had comments at the end of each line that had the conditions. So the Java code was real Java code, and you just put in placeholder variables for everything and put special comments around each placeholder variable to say this is what I want to replace. The concept kind of worked. It was, I think in the end, it was a little too hard to create those templates and have it all be valid Java code. It was doable, but you had so many places where you had comments around variable names. So I'd say like class 1, and around class 1 it would have a little comment that says class name. So I mean, it was nice to have the actual Java compiler checking the template to see that, yeah, this is actually valid Java code, and you had a decent idea that what gets generated would be valid Java. Because doing this, I mean, up here, I could have put some garbage in there, fat fingered something, and you'd never know until you get that compiler. But it's one of those things I'm like, it was an interesting experiment. I just don't think I think it ended up complicating things more than it helped. I mean, my goal at that point was to try to set up some really thorough unit tests. And the problem is when you have code like this is you'll never know if there's going to be some code that's conditionally included, and your unit tests might not hit it. And so you might not know until a very specific case comes through that block is bad. Whereas the stuff, when I was doing the special template engine, you'd know up front that, hey, that looks like a bad block of Java code, even if you weren't actually including it. So it was a neat idea, and there were some places I thought it was more readable because you didn't have the conditions interspersed. The conditions were on the lines to the side as comments, and I'll have to see if I can dig that up. I think I've got that code hanging around someplace. I'll have to find that and bring it in because I think that'd be interesting to see. But it's just another way to look at code generation. Okay, any questions? So when you get your Fowler book, I would recommend you read the preface. It basically describes his structure, and the first section that talks about this example. You can probably skim it more than anything because I've covered quite a bit that's in there, and I've extended on top of it. I mean, he didn't have quite as many examples there, but he gives you the general idea of what's going on with this. Okay, we'll see you guys next week.